neglected tropical diseases, we give mass drug therapy. So there should 90% fewer people will need the mass treatment, 75% fewer neglected tropical diseases, disease, and 100 countries will have to eliminate at least one neglected tropical disease, and 2 neglected tropical diseases are completely eradicated. Like that, there are certain goals have been made in the roadmap of the World Health Organization by 2030. If you see the progress which we have reviewed, look at this. In 2019, 1.74 billion people, they required interventions against tropical diseases, which is down from 2.19 billion in 2010. In 9 years, you can see 26 plus 19, that 35% or 45% reduction in that. And over 1 billion people benefited from at least one entity interventions. So this progress for 9 years was quite satisfactory, but though it was a 9 years period, we take it 2015 to 2019 in 4 years period. Now you can see highlights. Sir. So these are the details. I am not going to the details. Am I audible to the last row? Am I audible to the last row? Thank you. So I am not going to the details of the above all the diseases, but what I show, I want to tell you in a nutshell that 105 countries require preventive chemotherapy. 81 countries implemented large-scale treatments. 649 million people no longer require mass drug treatment. They are already cleared. And global burden of visceral stenosis and many other dead in neglected tropical diseases decreased significantly. I will, after giving a general glimpse on the neglected tropical diseases relating to sustainable development goals, I give examples of 3 diseases for elimination in 3 slides, for control in 3 slides, and climate change in a couple of slides. So this is the progress we have already done. At a glance, if you see, 43 countries and territories have eliminated at least one neglected tropical disease. See, the target was by 2030, at least 100 countries should be eliminating one neglected tropical disease. But by 2019, 43 countries have already eliminated at least one neglected tropical disease. Means we are positively heading towards achieving the goals. In addition to that, in 2019, Mexico eliminated rabies, Kiribati and Yemen eliminated lymphatic filariasis, Malawi eliminated lymphatic filariasis, Togo eliminated African trypanosomiasis, Yemen eliminated Myanmar eliminated trachoma by 2021, Gambia eliminated trachoma, and Cote d'Ivoire eliminated African trypanosomiasis. Now, if you see the global strategy of leprosy, it is given the yellow mark there, that is the up to 2019, and 2022 is this green mark. Then the target is that the way it is decreasing, we will be achieving the target by 2030 as regards leprosy elimination is concerned. Again, elimination of leprosy, lymphatic filariasis, visceral stenosis of Kala-Azar means bring down the cases to less than 1 per 10,000 population, so that no more it will be a public health problem. Now, I said I have given this in general. I said now let me give some examples how elimination happens, how control happens. See, this is about lymphatic filariasis. Lymphatic filariasis is a leading cause of permanent disability worldwide, and communities frequently shun and reject the women and men disfigured by the disease. I met some people here during tea time. They were asking me, telling me that they met me when I was a scientist in the Regional Medical Research Center. Yes, when I was working in the Regional Medical Research Center, I got a huge project from the place of World Health Organization. There were 5 global projects at that time. That was 1993 to 1997 or 98. India had one, Brazil had one, Africa had 2, and I don't remember another country. So Indian project was under me. I was the head of the Indian project. I took the area Khordha district and Khordha area and Pipli area. So for that we have to collect baseline data. When I was collecting baseline data, I visited some villages in Khordha. You will not believe, in every house there are 2 to 3 lymphatic filariasis cases, swelling legs or swelling lips, and most of them girls are manageable. I was shocked. Now situation has changed. How the situation has changed, I will tell you. That is the example I want to give. Now, what is lymphatic filariasis? Dr. C.S. Mishra knows, for those from zoology background, biology background, you know. Lymphatic filariasis is caused by nematode parasites. Uchera bacteria, Vujia malai, and Vujia tivoli. Vujia tivoli is not found in India. So you are bothered for Uchera bacteria and Uchera Vujia malai. In India, 95, more than 95% of filariasis cases are due to Uchera bacteria, which affect the lower part of the lips. They are transmitted by mosquitoes. So, when a mosquito bites, you can see the lower part, the human being, it takes blood along with the microfilariae. Microfilariae are the children of the adult parasite, larvae we call it. Then it grows in the mosquito, left side you can see, L3 larvae is written there, 47. This is the infective stage of the filariasis. When this mosquito, with this infective stage of larvae, bites a healthy human being, it releases the parasite. The parasite goes and the filariasis. This is the life cycle, this is the whole thing. Now, once upon a time, in the world of lymphatic filariasis, nobody thought that this disease could be eliminated one day. People thought lymphatic filariasis, we have to live with it. We live with it. We should know how to live with it. But this research carried out in 1990s changed the entire scenario. The little appreciation of the burden, inadequate means of diagnosis and inadequate tools of treatment, inadequate strategy to control the infection, there is little hope or anticipation that LA can be eliminated one day. Thanks to research and development in 1990s, today, not only there is a global program to eliminate lymphatic filariasis, always it is already 2 decades old and active in many endemic countries. But there is also both hope and strong belief that the targets of eliminating lymphatic filariasis can be achieved. Why has happened? If you, anybody who had eosinophila in their life, anybody, what medicine you took? Diethyl carbamide? I don't remember. I am telling you, the only one medicine, panosite, but whatever name, the chemical is diethyl carbamide saccharide, DEC. So that medicine is given for lymphatic filariasis. Because eosinophil interferometry is same medicine. So what happened? For any medicine you take, there is a clinical trial. But for lymphatic filariasis, anybody who is having lymphatic filariasis, they go to a doctor earlier, those days before 1990. They prescribe DEC, 600 milligram of DEC to be taken for 14 days. It was from time immemorial till 1990. Now why 14 days? Dr. Mishra, why 14 days? Is there any clinical trial on that? I found everything, no book, no publication, no clinical trials. Where from this 14 days has come? Finally, one person, Eddie quotation from USA, he cleared my doubt. Long back, in the 20th century, a ship was coming from Papua New Guinea to America. Papua New Guinea is heavily affected by lymphatic filariasis. To prevent the introduction of lymphatic filariasis to the mainland, they started giving BEC to every person in the ship, and it took 14 days to reach the mainland. And nobody, there is no spread of lymphatic filariasis. So it was concluded that 14 days treatment is probably treatment you give to everybody. So everybody is giving. Then scientists started working, there is no clinical trial how this is happening. Then 1990s, many scientists in many laboratories they started working, they found a single dose of BEC will do the same, give the same benefit as 14 days of treatment by BEC for filariasis. Therefore, a strategy was developed that in an endemic area of lymphatic filariasis, give single annual dose of BEC once in a year, and if you give it for 6 years to 80% coverage, lymphatic filariasis can be eliminated. And trust me, with this strategy, I eliminated lymphatic filariasis from Thailand, from Sri Lanka, from Maldives. So this was the criteria, the strength of science which helped to achieve one goal. What is this happening? Now, if you see India, this map, these are the endemic states by lymphatic filariasis. And the 272 districts in India are endemic for lymphatic filariasis. Because of this mass drug elimination, 72 districts have reached the point of elimination as a public health problem. So, India is also progressing well as regards lymphatic filariasis. You might be seeing when you go to Puri temple, everybody must be visiting. Those who have visited 20 years back, you might have seen on the roads of the Puri temple how many lymphatic filariasis patients with the shoulder and legs are sitting, how many are sitting now? No, nothing. So this is how it has been declined in India. You see, this global estimate initially in 2000, 198.7 million were having lymphatic filariasis. 2018, it has come down to 51.4 million. This was the success we got for the lymphatic filariasis. Now, coming to diseases for control. That example I have given you about elimination. I will give an example of control and prevention of neglected tropical diseases and dengue and other arboviral diseases. What are the other arboviral diseases? Chikungunya, Zika recently has come, yellow fever. Fortunately, yellow fever is not found in India. I must tell you, yellow fever is endemic in South America and Africa. And any scientist who work on yellow fever died. You did see the literature, but fortunately, it is not found in India. So, this dengue, chikungunya, and Zika are transmitted by two mosquitoes, Aedes aegypti and Aedes album. Below you can see these mosquitoes. And these mosquitoes they bite during the day. See, if it in other mosquitoes are night biting, malaria, lymphatic filariasis, they are all night biting. You can take precautionary measures in night biting. You must sit under a impregnated bandage or simple bandage. You can use a vaporizer, mosquito vaporizer. But the mosquitoes, those are biting in the day, during daytime, what are they going to do? You go for marketing. Can you go something to protect against the mosquitoes? No. So that is why this is a dangerous group of mosquitoes which transmit these diseases. And this side is Aedes aegypti, which breeds in any, 25 paisa coin, you might have seen students, you might have seen 25 paisa coins. That amount of water, if it is there, if you know banana leaf, that amount of water is there, it is educated and born, green and like the extent. It is such a adaptable mosquito. Aedes albopictus right side, you can see distinguished, there is one white band in Aedes albopictus, there are many Aedes aegypti. Aedes albopictus is a sylvatic species, means it loves nature. It will not breed if there is nothing from nature, leaf or something like that. They will breed in such type of right side you see breeding places where water collections are there. You might have read in the newspapers that dengue is going and spreading in European countries. Do you know how it goes? How did it go in European countries? Have you seen these Chinese lucky plants, lucky bamboos or something like that? Because of that, it has gone to Europe. So this is how they spread. Again, dengue has 4 serotypes: dengue 1, dengue 2, dengue 3, dengue 4. Among the 4 types, there are also genotypes. So that is the reason we don't have vaccine for dengue. Just like COVID-19, we do not have an active antiviral drug for dengue or chikungunya or Zika. We do not have a vaccine for these diseases. We do not have a proper gas management system for these diseases also. The only thing is fluid management, and we give intravenous fluid. And remember these 4 serotypes, because I am going to say about that, how it has come. See, this global distribution of dengue, how it started. It's not a very old disease. 1970s it started. See, first, this is dengue 4. Oh, sorry, dengue here. In 71 it started. Then 75, dengue 1 again. Dengue 77 again dengue 1. Dengue 4 in 79. Dengue 3 again in 80. 81, dengue 4, dengue 3. Then 82, 85 again, dengue 3. Now, by 2012, everywhere in India, all serotypes are present. It means, if you go to previous slide, these were pandemic, dengue was pandemic. When you go to 2019, dengue became endemic. Everywhere, all serotypes are found. So this is how dengue was spread. But what about India? If you see India, 1991, only 2-3 spots were there for dengue. 96, you can see how it has spread. 2001, you see, 2006, and 2003 by 2013, all villages are affected by dengue and chikungunya. This is the strength of spread and transmission of these agro-viral diseases. I'll tell you, give one example. You know who is the person on the left side? Yes, Chopra. You know how he died? By dengue. And for dengue prevention, when I was in World Health Organization, this was, I conducted several trainings for dengue prevention and control. After the training, this was, I went to a remote village in Thailand with 50 participants. We have in World Health Organization scientific and technical advisory groups. So we organized the scientific and technical advisory group for dengue and chikungunya once in 2 years. 2012 I organized it in Indonesia. Why in Indonesia? In the entire world, Brazil is the country which contributes to the largest number of dengue cases. In Asian countries, Asia Pacific, Indonesia is the country which contributes the maximum number of cases. So I selected Indonesia. In Indonesia, Bali is the state which contributes the highest number of dengue cases. So I selected Bali. I went to Bali for the program. My wife accompanied me because I was going to Bali. My secretary was there, that SPMN, he is from Bangladesh. Is there anybody from Bangladesh here? Very good. So here my secretary is there. And you know the middle person? Students. Who is he? I know all, they will tell. Sunil Sethi. Sunil Sethi was in Indonesia, in Bali with his wife. We traveled together while going. We are not introduced to anyone. While coming back in Bali airport, we are sitting in the executive lounge. He was also sitting. So my secretary, he knew him. He went to him, sir, I am such and such, and my son is a grandfather of yours and all these things. And my boss is going. He has come to conduct the technical advisory group on dengue. The moment he heard dengue, Sunil Chetty ran to me. Then he was saying, I have a big NGO. If you want to have control dengue for anything, you can ask me. I can give you many crores. We were just talking because I could not tell him that WHO doesn't accept money from an individual. Anyway, so this is, but he has given me his card, his personal number for anything. If you are, don't hesitate to call me. But I want to tell you, dengue created such a situation in Bollywood that everybody was terribly afraid of dengue by that time. Now, to sustainable development goals, three are related to climate change. We know that climate change is happening. It is happening. We all know it is happening. I am coming from Kodapur, and you see why I went to Kodapur for the first time by road. My wife went to Kodapur in 1966. She told with her father. She said there are many hill streams, this and that, natural beauties. You take some photographs while coming. I went to Kodapur, Sunamada, that central Odisha. I give it in a car. After crossing Bornpur, I was just watching where is hill stream, where is nature, where is what. Nothing is there. Climate change is happening. So temperature is increasing, and this is a newer challenge. I don't want to give you the definition of climate change. All of you know about that. So when the climate change is happening and temperature is increasing, and there are different models. I don't have a pointer, so I can just tell you like that. Different models of global warming. I proceed in last but one, the red bar. So it is predicted by 2100. There will be 3.5 degree increase in temperature, and this is the global scenario on the right side. Which country will have affected how much by the global warming? This is not important. All of us know about global warming. Anybody studying in +2 also knows about global warming. But what is important, I want to tell you here. Warm nights are increasing and cold nights are decreasing. This is a very important phenomenon for disease transmission, for many other things, for human behavior, and for social sciences can think better about it. So this is about climate. So I think I am going to close my talk. Now I thank all my colleagues in the institute, which I have headed in my career, and all those who have collaborated with me. I thank them. I thank you for patient hearing. Thank you.
One thing you must have marked, you are director of 5 national institutes of the country. Besides being the Vice Chancellor, you are director of 5 national institutes of India, and you are eminent scientist, eminent bioscientist, and this year you are honored by the President of India with Padma Shri. Thank you very much. Now we have Dr. B.K. Das is over here. ICAR Central Institute of Inland Fisheries Institute. We invite Dr. Das to deliver his talk, and time slot allotted by the organizers is for 20 minutes, and we request Dr. Das to kindly adhere to the time. Thank you, Dr. Das. Kindly, the stage is yours.
Okay, let us go straight to the discussion. I am just focusing what we are working in simply for developing the women empowerment, particularly in the fisheries sector. So look into this. This is dedicated to the 8th March for the International Women Day. What we look into this in a glimpse to see, starting from river ranching to different soil health card, building the community empowerment among the women, and if you see what is a different process takes place for the development in the different stages, from different aspects, from the environment, from the meaningful choice to the different roles in the small scale fishery. Why I am focusing this slide, if you see 2023 is the International Year for Small Scale Fisheries. That we are looking into how the small scale fisheries contribute to the livelihood, nutritional securities, and let me see what the Professor Das told about the disease cure also. You could see anemic disease, other things. Small rural women, the small indigenous species, a greater room for this. And small indigenous species is not documented in any of the statistics, but the production status. Around you could see maybe 10 to 20% of small fishes contribute to the water, the amino acids, fatty acids, or disease that the anemic conditions that kills the people living in the riverside, wetlands, or river, anywhere. They take this fish and you find the others what the health profile is increasing also. Again, these are some of the canals we work for this with the gender women for the developing in the Sundarban areas, because largest ecosystem, mangrove ecosystems, just like people say dhan, pan and wind. These are the livelihood of eastern India, and these people mostly because of the cyclone operations, they think we work on this in by the involving of these people. Again, these are the some of the, again the Sagar Island, one of the part of this is that the people with the fisheries interventions, we increase their livelihood in the different aspects of this, and look into this, how the muscularity of women reproduce in the society takes place in the productions, and the community management roles. If you look at these three, how this work in these production tools, how they, just like we call the gender equity and the participatory roles, how the both family business goes into this in the largest Sundarban regions where people work on this. Again, reproduction role in this women starting from the small households to different type of activities, going to the community role care participatories. So involving this, again, if you want to involve this woman into the policy decision making, even if also all these things, the degree of participation involves how tools to come forward into this, the societal development. Looking into this, we record into how the fisheries in the reservoirs on the cage culture practices, their involvement in increasing the high level of productions in the different aspects. Again, drudgery and occupational hazards plays an important role in these systems. Again, each woman how they involved to input in the different aspects from the, if you look into this different aspects in the processing, valuation, marketing, and these are the different participations in the women from packaging to the marketing also, how they go forward in the different sectors. Again, we have studied in this occupational health risk and this, people see different in the societal, in the living in this, people see how the female is going to be equal or little higher risk in the some of the like skin-borne and skin diseases or pricks and bites. In some of the cases, there have the higher levels of the occupational hazards when work in this the systems that play major roles, that people with 100 fishermen are likely to suffer more than the occupational hazard sector, well fishers also. Again, if you see this piece called diagram that attempts to highlight the constant challenge with the root of these things, practical gender problems with the socioeconomic status, asset, lack of awareness, low social participation, socio-cultural restrictions, low media exposures, lack of decision-making process, and lack of institutional and market linkages, no vocational training also. So these are some of the gender constraints it will go to achieve the societal benefit and empowering women in the different stages. Again, we go for the need for empowerment with DPRA participated pressure techniques in the different remote villages, build up their constraints, then buildings. After that, we go for their problem rankings and addressing all these things. So these are the problems ranked in the different aspects, starting of physiological, educational, economic, social and political rankings. Then how the intervention starts from one to another. Looking into these interventions, we started from last 4 years of interventions in the different aspects in the chronological mention and sensitizing field augmenting women into the business in the different capacity building 2019 to last year because in the COVID years when 1100 women have been sensitized and input for the livelihood shoppers. Again, we go for the interactive women participations through buildings in the remote parts of the Sundarban, how to participate in the capacity buildings and the livelihood operations. Again, these are the ornamental fisheries. We got under Prime Minister taking a flagship program to build up the ornamental fisheries and the economic enterprise. So we started till now, when we hear Chunokal area to the key to find one village 15 women in Nepal and linked with the Amadou marketing system to be a part of Modulated district. We are building up the capacity in the women of these things. And if you go for ornamental fisheries, means staying at home also, but sometimes they can build up the marketing strategy, earning everything in the different parts of the ornamental fisheries, from packaging, collections, live food, breeding, and then you can preparing some of this. So many enterprises from the family enterprise, uptimes that can use as a economic enterprise, not on the livelihood options. So these are the setups, you can be processing the different setup you can go, and from different tanks to the small scales to large scales in the process of the ornamental fish setting up. And these are the some part of the different parts of the country, going to the tribal people, rural people, meaning them to staying at the rural sector, how can build up the enterprise here. So again, we could see that marketing, how the women is involved around, we could see small indigenous fish, around 15.6% contribute to this, and 84.4% will be going to other part of this women involvement. Again, look into this and for some of the HAPA-based systems for small indigenous species, training in there. You can go for the small like Morala, rich in vitamin, micronutrients, iodines, which can supplement you for the need for the things that can use for this. Again, look into this soil health, human empowering, seeing that how that can be contributing to the different parts. And from where we distribute this is the Sundarban Development Minister, who was associated with the upliftment of the community participants. For the nutritional interventions in different parts, by this you could see this is a small scale nutritional security from rural Sundarbans. You could see these are the study we take with the medical groups, how the feeding the small fish that can increase the anemic blood hemoglobin, blood calcium, blood phosphorus. So that is a study, and we study the male, female child, which is the underweight, normal weight, how these affect in the distributions of the according to the BMI. Again, you can see that how it is increasing by taking the small indigenous fish in their diet. So these are the after and before studies, these interventions are these hemoglobin and other things that increase. So this indicates small indigenous fish also will set as a medium. You could, if you have less money to invest for your health, you can take this fish for your fish. Again, these are the different process of this study, and look into this, and where when farming to the ecosystem by to integrated wetland management, because large wetlands gives less production. We involve these women people, the ancillary activities of the agriculture, poultry and other things for the integrated management, and they started the livelihood in the mushroom farming, other farming, the vegetable farming, then poultry, goatry, then finally, and these are some interventions we go for that thing, and finally look into that the total involvement in this and agricultural sector, fishery sector, bringing into a 12 platform where we can empower the systems, and even if we go for the human empowerment lot of things in the Gandhi Jayanti Saptah, building the human force into the Gandhian perspective, how this will be involving the different aspects, and we do a lot of activities to encourage the women into the society, bringing into the core sector of the not only the rural economy but also the research fund, education, and again starting into the environment where you work, so that the environment should be good. So we build an enabling environment for the women in every platform, looking into the health, hygiene, and the environment also. So this is the changes that can take place in the small scale fishery, building the aquaculture into the enterprise, and bringing it to the normal scale in the large scale. With this diagram, I finish that thing to take. I will take the time that we are doing this.
Thank you so much, Dr. Das. Let us give a big hand for Thank you. Now, my friend will introduce the case.
Thank you, sir. Thank you so much. Now, Ms. Sanjini Kumar will join us online. She has joined the Reserve Bank of India with an unusual educational background in English literature and journalism. During when she was 17, she occupied the senior positions across departments of supervision and foreign exchange management. She took a 2-year sabbatical to complete MA in public policy at the UT Austin, Texas, USA during the period of 1999 to 2001. She left Reserve Bank of India in 2007 to join Bank of America Merrill Lynch in the year of 2007 to 2010. And then she moved on to the PricewaterhouseCoopers 2010 to 2015, where she was a partner heading banking and capital markets practice for India. She was the founding CEO for Paytm Payments Bank briefly before accepting the position of country business manager for Citibank's Consumer Bank in India 2017. In the year 2021, ma'am moved out of Citi and set up SALT, www.salt.one, a startup building a woman first fintech platform. She read, travel, and write short fictions because there is always something quirky somewhere that needs expression, as she says. So let's listen to ma'am.
Oh, thank you. Thank you for that very kind but long introduction. I know that we don't have a lot of time today, and first of all, I want to say really, really happy to be with you all. It's always a pleasure to interact with students and young minds, and for me, there is also people in that part of the world. One of the things is there is a it wasn't there earlier, but it's okay. Now it's gone. Okay, good. So can somebody so essentially, I want to say a big thank you to the organizers, to the National Science Congress, and to your college organizers, your dean, your vice chancellor, your associate dean, and personally, it's hope you heard it. So without further ado, I'm going to dive right into the subject for today. And we're going to talk about women empowerment and sustainability. Related to the day-to-day function to pointing to how we will this day. Hello? Hi. Okay. I think this is a sign from heaven that I have to come to your campus and speak to you, which I'll do later. Let me just go ahead and complete the topic for today. And we're talking about sustainable development and women empowerment. And I was saying that I'm hoping that my Wi-Fi will hold. I was trying to share with you our experience of building SALT, which is a platform for women to use financial services and products. And I wanted to illustrate through our experience the point of how women are better participants in a better world, in a more sustainable world, if you empower them or if they feel empowered to take of their finances. So I'm going to get subject because, as I said, your theme for this conference is very large and will require a whole, and just the subject of women empowerment and sustainable development requires a conference by itself. So I'm going to be short and I'm going to leave a little bit of time for people to ask questions. But one thing I wanted to tell you is that so as you just heard, I was working at Citibank. I was heading the consumer bank for Citi. As you know, Citi has the prime clients, mostly wealthy population, urban population. And even in that, one of the interesting things I discovered when I started to work at the consumer bank is that we had much fewer women customers than we had men. And even my personal friends who were CEOs of companies or CTOs or various senior women, we realized that even they were not as proactive in managing their own money, and they would often leave it to their spouses, for example, or to their chartered accountants or to some name. And I'm sure all of you know women in your lives who are very capable of taking care of many things. So most women are actually celebrated for being multitaskers, and they are very good at taking care of homes as well as their work. Many of them set up astonishingly successful businesses. Even if the businesses are at a small level, they're astonishingly successful because they create their brand, they create their relationships, they go through the whole supply chain, they find artisans or whoever is needed to make their work successful. But when you dig into these businesses and you start to see who actually takes charge of their money, A lot of times it is a husband or a partner or a brother, or many times a father, or many times an accountant. But whether women just think of that as a job to be delegated, as a job that somebody else can do for them. One of my friends who's an entrepreneur, she said, I always thought of it as a blue-collar job that anybody could do. The problem happens when you have to actually make decisions that have to do with finance. For example, when you want to grow your business bigger, or you want to bring in an investment, or you want to bring in a shareholder. These are all decisions that have very important bearing on your long-term well-being of your business. And that's the time when your voice becomes small compared to the voice of the person who's managing the money, and therefore many times you become the lesser powerful partner. So the reason I'm giving you this example is because when we decided to set up SALT, we spoke to almost 250 women and in long form interviews. And one thing that came across very clearly is the fact that women are very good at making decisions about money when it comes to small ticket sizes or day-to-day decisions. One woman we interviewed said it in a very classy way. She said, in my house, my mother took all 4-digit financial decisions, and my father took 5-digit and above financial decisions. I'm belaboring this point for you to understand that when we say women empowerment, a very important thing that we don't pay enough attention to is the concept that money is indeed power. So who controls the purse, controls the decisions, has the power. So you cannot think of a more equal world or a more, because equality between genders is an important principle of sustainability as defined by United Nations and as understood by all of us, right? Because women are 50% of the world, and if you are keeping 50% of your population, if 50% of your population is actually living in a way that they don't have the right to take decisions about how to use their money for the well-being of themselves, their families, their communities, their countries for that matter, their companies, then that obviously is not a world that is sustainable. So the United Nations Sustainability Development Goals, I think it's goal number 25, specifically talks about gender equality in finance. There are also other goals that have to do with access to finance and women having access to resources. So if you put it all together, it's a very key principle of sustainability that women should have equal access and equal power. And I'm going to focus completely on finance because a friend of mine, Karuna Nandi, who's a well-known Supreme Court advocate, she was having a chat with me on a panel, and she said this very bluntly. She said, money is power. And if money is power, and if women are away from it, then obviously they are away from power. And that has a bearing on everything that happens further down. Whether it is a decision to put a drinking water, hand pump in their backyard, which makes their life easier on a day-to-day basis, or whether it is a decision to buy electronic good like a mixie or something which frees her up from the labor so she can spend her time doing something else, or whether it is starting up a small business, or whether it is actually growing a big business, or whatever is that decision is important. That decision involves money. And therefore, when we thought we will build SALT, we wanted to go to the crux of that issue of how do we balance that power? How do we make sure that women who have access to money, because pretty much most women, even if they are homemakers, like in your case, because you're students, you can think about your moms, your aunts, your sisters, all of them handle money in some shape or form. But what ends up happening is that they limit their paradigm of decision making. So they will say, I can take a shopping decision. So the best example that I always give is that if somebody has to buy a pair of shoes for 2,000 rupees, I think they will go ahead and make that decision without thinking. But if they have to make that 2,000 rupee investment into a mutual fund, for example, or buy a health insurance, they will not do it by themselves. They will go and ask 3 different people. They will be worried about, what if I make a wrong decision? And that's because we've always controlled that decision-making paradigm for women. And that just does not happen by somebody telling you explicitly that you cannot make that decision. So a lot of people wonder what is the need for this empowerment, and you're all young people, so I want you to think about this very specifically. That a lot of times people think that this whole women empowerment thing is a very, it's an excess, it's an excessive indulgence. That why do we have to think about women empowerment? Men also have problems, men also have deprivations, men are also poor, fair point. But think about this, right? When you are, nobody comes and tells you you cannot do this, but you're conditioned to impose those restrictions upon yourself, because even when you are a young girl, if you go out on a, in an evening and something happens to you, 99% chances are that from next day you will not be allowed to go out in the evening. So you will limit yourself to the household. You will limit yourself to what is considered safe, what is considered not difficult. And that over a period of time begins to play into your psychology. So in our project, one of the things that we really tried to focus on was understanding what were these psychological barriers to equality, what were these psychological, and because you can't change society without understanding what are the vectors that are driving inequality. And if we are talking about a more sustainable world, a more equal world, a world where more people have access to power, then we have to change that, right? It won't just happen because the governments will change and policies will change. Even our day-to-day, footing of equality has to change. And therefore, and because our primary business is money, we wanted to address this psychology of feeling equal, of feeling empowered, of going ahead and making that decision. That's one long point that I wanted to make. I want all of you to think about it. I want all of you to be able to do something about it. And the second point that I wanted to make was, why is sustainability tied so inextricably with gender equality? Because again, many of you may have that question in your mind. You may not say it, but you may have that doubt that, it's important to have a better world. It's important to have, reduce global warming. It's important to have, alternative sources of energy. It's important to save the planet. It's important to not generate waste. All of those are very intuitively understood causes, because in your day-to-day life you understand and the importance of dealing with environmental sustainability. But gender equality is not so intuitive as a sustainability goal for a lot of people. But so I want you to know two things. One is that yes, it is, because it has already been included and enumerated. I can tell you, you should look at the sustainability development goals, and you will see that this emphasis is very clearly articulated. But that's somebody else is telling you that, and you may or may not like or agree with that. But now think about it yourself. And when you think about it yourself, you think about it, that 50% of the world's population is women, and the reality is that their lives have constraints and problems and challenges that are similar to, but also different from the challenges that men in equal economic strata face. So, for example, let's talk about migrant workers, because a lot of us will know that no migrant workers, right? Because you're sitting in the eastern part of the country where I come from, and I'm staying in Mumbai, which is where a lot of migration happens. And so men typically migrate for work, right? Seasonal migration or work-related migration to urban areas from rural areas is largely men. And when men migrate, they face a lot of problems, a certain type of problems. Those problems can have to do with, housing, sustainability of income, healthcare, inability to have a voice in the local political ecosystem, and various, a very fragile economic infrastructure that does not support them as much as it supports probably the locals. So that's a set of problems. The women typically are left behind in the village, often with their children, and they probably get money which the men send. And they have a whole series of different issues. How to even get this problem get this money without paying commission to somebody, for example. How to pay school fees for your children and various things. So many of you know that I was the CEO for KTM's Payments Bank. And one of the things I did at that time was to travel a lot to rural areas to understand
what are the type of problems that women in rural areas actually deal with when it comes to money. And a lot of, and I don't have time to talk about all of this, but basically what I want you to understand is that women do face similar problems, but also incrementally different problems. So if we don't give them the voice, if we don't give them the power, if we don't give them the tools that they can deal with those problems, then those problems tend to get neglected and pushed under the carpet. And they continue to create problems for generations to come. Like you look at just access to drinking water, right? Access to drinking water, or inevitably ends up becoming a woman's problem because she needs to cook, she needs to give, put food on the table and put water into the house. So many women just trek for miles together to just get drinking water. And if you are not creating equal footing, equal empowerment, then you are never going to address that problem. And it's a very large problem and it has a bearing on many things downstream. So I want you to think about why gender equality is such a major tenet of sustainability development goals, and therefore what is it that we can do about it. And in our case, for example, I decided to set up to help this from the perspective of money. If you recognize that is power and that will level the field. In the similar way, somebody else can do the same thing using other tools, right? Technology is a very major effort. So many of you know that the internet also has this gender divide, right? Internet is largely male. A lot more men are able to access internet than women are able to access internet. And that itself creates barriers, that itself creates exclusion, that itself creates disempowerment. So what are the main? Education also is one. Skills is one. So what can we do as you think about your career choices, as you think about the world that you guys are going to live in and work in and build, you should definitely pay attention to this because it is actually, if you ask me, apart global warming and gender equality are the two most important challenges that your generation has to deal with. And you can use technology to solve for it, or you can use technology to make it worse. Because one of the things we discovered, one of the reasons that pushed me to build this company, is because I realized that a lot of the traditional biases against women also get coded in the technology if a lot of the coders and builders and product managers are all men, because that's where they're coming from. They're not going to just change on their own, and therefore you do need more women to take charge and start to change that, right? And that's one of the things that I decided to do for myself, for my gender, for sustainability. I'm going to stop here and give you 5 minutes for questions if you have.
Thank you so much, ma'am. Thank you so much, ma'am. Now I request...
No questions?
Ma'am, before... If there is any questions, you can go ahead now. Well...
As you already mentioned before about the conditions we face in the daily life.
You can ask me questions. You can have my mail ID from your organizers, and you can just ask me whatever questions you want to ask. Okay, go ahead and ask that one question if somebody is there. I can't hear you.
Hello, ma'am. Ma'am, as you already mentioned about the problem you face in the regular basis about going out in the evening, and then if anything happens, it may not be our fault, but it happens in the society. So what should be the step against it? Like how to prevent it, or what should be as a role of a human or as a woman, what we can possibly do to avoid it?
Yeah, so one of the challenges when we talk about gender is that it is always put back on you, that you have to solve this problem also. But frankly,
the problem of you not having a safe world is not just your problem. It is the problem of a lot of men who make it an unsafe world, right? I don't think you should make this your problem, but I'll tell you what we can do. One of the things that definitely helps is just having more women in power. And in fact, my husband, who's a social scientist, always says this. He says the only thing you need to do to make this world a better place is to have more women in administration and police. If there are more than 50% police women, this will be a very different place for women. It's as simple as that. And so do we have enough women who are stepping up to get into those jobs? Do we have enough women who are who are willing to be out there to do those jobs? Those are the things that are going to make a difference. So like I always give the example of the world of finance because that's what I understand. And when you realize that, if men are primarily building, then they are building for men. So you need to be out there and you need to be building for that. In the same way, law and order is a situation which is currently, you go to a police station, you are still not safe. You're on the road and you're not safe, but you go to a police station and you're not safe because 100% chances are, like 95% chances are that when you will go to the police station, there'll not be a woman constable there, right? So how do we, over a period of time, increase this? But then when you dig into that problem, you start realizing, why are there not more women into these jobs? Because they're not studying. They're not studying for these subjects. They're not getting that type of coaching or training which the men are able to get. And therefore you have to constantly think about how to get, and it won't happen overnight. So there's no point in getting frustrated and saying that it's not there. You have to keep chipping at the problem and keep doing small things, and over a period of time, hopefully it will get better. It's already better than it used to be, right? I mean, I grew up in a village in Bihar, and then I studied in Patna, and I can tell you that it has gotten better. Even in smaller places, when I now go, I see girls taking their cycles and going. The other day I spoke to some girl in my village. She got a job in a school. She's bought a scooty. She drives 20 kilometers every day to go to the school and teach and come back. I'm very happy to see that change. Of course, it should be more. It can be a lot more. But the fact that it's happening is heartening for me.
Thank you, ma'am. Thank you.
Thank you. Now I request Dr. Parasar sir and Dr. Bhavya ma'am to felicitate Ms. Sanjini Kumar ma'am.
It is an excellent talk by Sanjini, because she is the world leader in the corporate world. I know personally her, and I request her that she should visit KIT University. And the KIT University is the largest and biggest university in the world and single university in the world. And our pleasure, so that I can tell you that in this hall, more than 40 international students are there. Means 40 country students are sitting in this room. Looking very small, but 40 international, and with all the directors are there. So because you have, I know that you have meeting 2 o'clock, so it will not take much time. So again, on behalf of the organizing committee, on behalf of KIT University and KIT University, we welcome you again. And I hope very soon, maybe March or maybe April, visit our KIT University, and you can have a look and see how you can give another in corporate world. I am also interested that you can become part of this university. Thank you very much.
Thank you so much. Thank you for inviting me. Areva, that is beautiful.
Yes. So this is university.
Yeah, this is handmade and made by tribal students of KISS University.
Okay, very beautiful. Yes. Lovely. Thank you, thank you, thank you so much. Bless you, everybody. Have a great conference.
Thank you so much, ma'am. Thank you.
So on behalf of this chairing the very nice and timely all the finish, we a special thank to Das sir, given a very nice talk, and our Padma Shri awardee, and a special thanks to C.R. Mishra sir chairing this session, because this is the lunch time and we have finished very food and beauty. So thank you very much. So we are going to end the sessions now. We have the lunch and we have the schedule. We can meet at next session. Okay, 2:45. 2:45 we meet in this hall. Thank you very much.
of Agriculture and Technology. Professor Mishra is an eminent zoologist and has carried out commendable work on the earthworm ecology and biotechnology. He is a fellow of National Institute of Ecology with more than 100 international publications of international repute. With all these galaxies of scientific persons, I, Dr. Rosalind Patnaik, once again welcome you all in this session of presentation. Now, I would like to invite Dr. CSK Mishra sir, Director CVSH OUAT, to take the chair and preside over the session. To begin with, this first presentation of this session is by Professor Bedang Das Mahanti on the topic High Energy Physics, Recent Discoveries, Societal Applications and Towards Restoring Gender Parity. There are many awards and recognition glorifying Professor Bedang Das Mahanti. His biodata is so rich and voluminous that will take hours long to cite all of them. So keeping in time limitations, I would like to cite some of his prominent awards and contributions he received. Professor Bedang Das Mahanti is currently professor at NISER, Bhubaneswar. He is a prominent scientist not only in our country, but also has a rich experience of working in international institute of repute. In India, in his early years, he worked in Variable Energy Cyclotron, Kolkata, then Homi Bhabha National Institute, Mumbai. Then internationally, his work in CERN Geneva and Lawrence Berkeley National Laboratory in the field of experimental high energy physics is praiseworthy. Apart from Santi Swarup Bhatnagar Award in the year 2015, which is considered to be the Nobel Prize of Indian Science, he is a fellow of all the 3 prestigious Academy of Science like Indian National Science Academy, INSA, New Delhi, National Academy of Science, Nasi, Allahabad, and Indian Academy of Science, Bangalore. He is also a JCBOS National Fellow. Recently, in the year 2020, he was elected as a Fellow of American Physical Society, and in the year 2022, he became the India Star Allies Collaboration spokesperson. At present, he has more than 250 number of publications in highly cited international journal of repute. He had greatly contributed in new antimatter nuclei, etc. We are proud and privileged to have you, sir, among us. It will be our good fortune to listen to you and your work, sir. It's over to you, sir, for your presentation.
They have to listen to you.
Thank you very much for this very generous and kind introduction. First of all, I would like to thank the organizers for giving me this opportunity. Hello. Hello. Yeah. So thank you very much for giving me this opportunity to speak here, and especially Professor Mishra for insisting that I come to this seminar or conference which is related to sustainable development with women empowerment. So I thought a lot, how do I fit into this topic? So my presentation has 3 sections. First, which is I'm most closely associated. What are the recent discoveries in high energy physics? And I'll try to tell it in a very simple way. Second is these experiments which we do are in laboratories which require several thousands of millions of dollars to build. So what do we give back to society? So I will discuss about 2 examples, and certainly that is related to development and maybe sustainable development. The last part of the talk will be what are we doing to restore gender parity in physics in particular and science in general. As you will see, that needs a lot of work, and mostly scientists always try to take up issues where we face problem, and high energy physics is known to take up issues, lead from the front, how to rectify such deficiencies. So let me on the first part tell you what excites me to do high energy physics. I'll start with electron. And I'm sure all of you know what is electron. But just to put in context, we have studied that it's a subatomic particle. I mean, atom consists of electrons, nucleus. Electrons move around nucleus. That is what is an atom. In our school, we have learned that the mass of electron is 9 into 10 to the power minus 31 kilograms. That is, it is 0.00000, some 30 zeros, 9 kilogram. Its charge is 1.6 10 to the power minus 19 coulombs. It has some quantum number called spin, half, and most important application is flow of electron leads to current. And you know who discovered electron? It was Joseph Thomson who discovered electron, got Nobel Prize in 1906, and such a fundamental discovery, we can't even think of any development without flow of electron or current. So what has recently happened is, this is a picture in the Netherlands group.
Scientists used a device called a quantum stroboscope to freeze the electron's motion at different stages, just as you would freeze a hummingbird's wings in flight using a regular stroboscope. The resulting video has been slowed down and looped to show the motion clearly. For MSNBC.com, I'm Alan Boyle.
So, seeing is believing. If you come to NICER or Institute of Physics or wherever there is a transmission electron microscope, you can see atoms. So atoms exist. And what I showed you is electrons. So those are photos of electrons. So people have also seen electrons, and they do exist. And of course, flow of electron is current. Now the question that we posed is, you saw the mass of electron. For any practical purposes, you can take it as 0. 0.00000, some 30 zeros kilogram. We never worry about such a small mass. So if electron had 0 mass, what would have happened? Well, first time a proper definition of mass was given by Newton. Newton says mass is nothing but quantity of matter. In his famous book of Principia, he said that. Then came the other great scientist, Einstein. When he gave his special theory of relativity, he said that any object which has 0 mass will move with speed of light. It will never come to rest. Example is photon. Always moving around with speed of light. If electron had 0 mass, then a special relativity which holds till now, then electron would have also moved with speed of light. Atoms would not have formed. We will not exist. So don't take the mass of electron lightly. Just because it is not zero, it can move with any speed, finite speed, less than speed of light. And hence, atoms can be formed. So, what is this origin of mass of electron? Because if it would have been zero, we would not have existed. Okay? The other question is, what would have happened if the electron mass would have been 1,000 times smaller or 1,000 times larger? 10 to the power minus 31, you divide by 1,000 or multiply by another 1,000. What would have happened? Again, we don't think about it, but physicists do worry about it. If that would have been the situation, again, all of you have read about Bohr orbit, sometime in school, colleges. This is the radius of the orbit of an atom, Bohr's orbit, okay? And denominator is mass of electron. So if mass of electron would have changed by 1,000 times, more or large, the atomic radii would have changed. We would not have been like that you see, look, world looks so nice, you know, you come into this room, we are some few feet tall, either we would have been giants, 100 meters, or we would have been Lilliputs. So world would have been very different if mass of electron would not have been what it is. So this worried physicists a lot. Who gave the electron the mass? I will not go into the details, it would be a technical talk, but all we found out is mass can be generated by interaction. And to prove that theory, physicists need to discover a new particle called as Higgs boson, often popularly called as God particle. So it took 50 years to find that particle since it was hypothesized. And it was done at Large Hadron Collider, 4th of July 2012, that's the facility where I work, discovered this Higgs particle, and following that discovery we know how electron got its mass, why electron mass is what it is, and the implications are here. Now to discover that, it needed for us to build one of the largest machines, accelerators in the world, called as the Large Hadron Collider. It's a machine which has circumference 2 pi r of 27 kilometer, almost like Cuttack to Bhubaneswar, some distance like that. Not only that, in order to operate that accelerators, we have to make superconducting magnets, 9,000 plus of them, which needs to be kept at temperatures minus 271.3 degree Celsius. Minus 271.3 degree Celsius. Imagine what engineering and technological challenge it was to reach to that temperature and what could be its applications. But we needed it for our accelerator. Reaching such temperatures, cryogenic facilities which needs to be created could have impacts on other developments, but the technology was built for this purpose. Not only that, in the facility we need to maintain pressures which are 10 to the power 13 times smaller than what you encountered now. So that is again another technological challenge, how to create vacuum environment to that level, which is even 10 times less pressure than what you would find in moon, for example. Now, we wanted to collide two protons at very high energy. Now, we will be circulating these protons. You will see in this video, I will just play. They have, it has to be energized to such high energies that a proton takes 11,245 times it moves 27 kilometer in a second. In 1 second, a proton moves 27 kilometers How many times? 11,245 times. And the data that comes out, if we record, every year we can fill up 100,000 dual layer DVDs is the volume of data. So you can see what it is triggering. It is not only triggering technologies at low temperature, in vacuum technology, but also data mining, data science, handling big data, and of course accelerator technologies. So I will walk you through this 2 minutes video of this process of discovering this Higgs particle in that facility, and let me play you the video. So this is, we are going to CERN, which is in Switzerland, in Europe. That's the accelerator. The strip there is the airport. You can compare. This is the 27-kilometer circumference. We start with a hydrogen bottle. Ionized hydrogen is proton. Protons get accelerated in a linear accelerator to higher energy. Then it goes to a proton synchrotron booster, still higher energy. Then it goes to another level of acceleration fed to that ring, which is the proton synchrotron. After accelerating there, it goes to the next level of acceleration, which is called as the super proton synchrotron. It will now feed. That's where I did my PhD around 2000. And then it is fed to the Large Hadron Collider. Two proton beams moving in counterclockwise direction, and they collide. And we have detectors all around the collision region and start taking data. That's the detector. They collide, particles come out, and we try to record that event and analyze and see if we have Higgs boson. Now the data is so huge, it has to be transferred to a data center, processed, digitized, and what we found is the computing needs are tremendous and one facility cannot do. So we had to link all the computers in all participating countries like an electric grid. We formed a computing grid, and that computing grid, all the resources in everybody's institute was used to process this data. And you will just now see that's the name, grid computing. Just like electrical grid connects everything, similarly a computing grid was connected all across the world to process this data, reconstruct the event, and then discover the Higgs particle. What physicists do is plot histograms and try to look for peaks as a signal. And that's what you will see. The histogram gets filled up and you will see a small peak, and that's the signature of the new particle called as the Higgs boson, which was discovered on 4th July 2012 with 99.99% confidence level. We can actually put confidence level to anything that we measure, and subsequently it has been again verified, rechecked, and the significance has been quite large. Of course, when we found out that how electron got its mass, it got its due publicity. Not a single newspaper left it out because it answers why we exist and why we are what we are. And the two theoreticians who had hypothesized this idea, Peter Higgs, after which Higgs boson is named. Boson, by the way, is in honor of our Indian scientist S.N. Bose, bosons. And Englert, they got the Nobel Prize for hypothesizing this idea, and the experiments got credit for discovering it. So first thing, what we discussed is how electron got its mass and why it's important. The second topic which I want to discuss is, can we recreate the universe in laboratory, early universe? Most of you may have come across this word Big Bang. That is how universe got formed. It has various stages. When universe was a microsecond old, you had a free systems of quarks and gluons. What are quarks and gluons? These, you know, atom. Atom consists of a nucleus. Electrons are moving around it. Inside the nucleus are protons and neutrons. Inside these protons and neutrons are particles which all of us are made up of. They are never free. You never find a free quark like an electron. They are always inside proton. Proton is inside nucleus of an atom. Now, when was it free? It was free when the universe was a microsecond old and temperature were 10 to the power 12 Kelvin. This room temperature is 300 Kelvin. So when temperature was 10 to the power 12 Kelvin, they were free. So why else should we create such a system in the laboratory? If we manage to create, we are going to create a microsecond old universe in the lab. Why else? So here is an example I usually give. If I give you water and tell you nothing about it, then it's very difficult for you to tell what is the property of hydrogen and oxygen. For example, hydrogen is a fuel, it burns. Oxygen supports burning. Many of us has done that experiment. But water extinguishes fire. So if I give you water, it's very difficult for you to tell what would be property of what it is made up of, hydrogen and oxygen. Similarly, if I give you all these atoms and everything, you cannot tell property of quarks and gluons, which all of us are made up of. So if we create a free system of quarks and gluons, we can study its property. Property of what? Property of each one of us. Whatever you see in this world is made up of. So that's the idea. So that was made just to give you a glimpse of what temperatures, what I mean by 10 to the power 12 Kelvin. This is the temperature which is lowest recorded in the laboratory. If you go to a research institute which works on trapped ions, you will find 10 to the power minus 6 Kelvin. This is the temperature of the universe. We can measure temperature of universe. It is 2.7 Kelvin from the cosmic microwave background radiations. This is the temperature of this room. The temperature in the sun, solar surface to interior, is up to 1,000,000 Kelvin. If we have a thermonuclear explosion of a star or a terrestrial, you can reach 10 to the power 9 Kelvin. And what we reached in the laboratory is 10 to the power 12 Kelvin. Matter melted into its constituents and free quarks and gluons were formed. Now I said we can study the property. So one property I will show you which we measured of this matter at 10 to the power 12 Kelvin, a microsecond old universe, that was its fluidity or viscosity, how freely it flows. More the viscosity, less freely it flows. You know, that is an experiment which is going on. In that beaker is pitch, one which we make roads. And it is placed inside a jar so that external conditions doesn't affect. Its viscosity is 230 billion times than water. It's very viscous, doesn't flow. And you can see there is a beaker below and there is one drop just about to fall. This experiment is going on since 1927 and only 8 drops have fallen. That viscous, and nobody has seen exactly when the drop fell. Of course, now we have CCTV cameras and you can record it, but then it was, so everybody wants to see it will fall, but it takes years to fall. Okay? So that's highly viscous, doesn't flow. Now this is what we measured. We measured the flow of what? Flow of the matter all of us are made up of. That's the blue data point. And then there are some theory calculations with different viscosity. No viscosity, 1/20th of viscosity of water, 1/10th of viscosity of water, or 1/6th of viscosity of water. What we found is the viscosity is close to 1/20th of viscosity of water. That means the matter which all of us are made up of, if heated to such high temperature, flows much more smoothly, 20 times smoothly than water. it is by far the perfect fluid. That means it is the fluid which has the lowest kinematic viscosity known till date. Okay, so maybe I will just skip that video. Let me come to the third discovery, which took, all these have taken last 10 to 15 years. Okay. Now the last one is gravity. All of us have read this equation. F is equal to G m1 m2 by r square. Two bodies with mass m1, m2 separated by a distance r will feel gravitational interaction equal to G m1 m2 by r square. Newton gave this. Do you know it is not correct? Yeah, it's not correct because it tells force is instantaneous. But Einstein said nothing can move with more than speed of light. So how can this body know instantaneously there is another body? So that worried Einstein, and he actually gave a theory of relativity whose approximation leads to what Newton said. Of course it works, otherwise we cannot put satellites. This works, but in the fundamental level, that force cannot be instantaneous. There must be some way this body knows there is another body, and it takes finite time for that body to know, and then there is force. So he said it's not instantaneous, the space and time that you see is actually curved. Again, very difficult to imagine that the space and time, by the way, space and time are related and it is curved. Okay. So he said, you know, space and time is like a rubber sheet, and you have a heavy body, and that body causes a deformation. And when another body comes, it gets rolled towards it, attracted towards it. That's how gravity works. Okay, nobody believed. He gave the theory, and then it has to be proved. Then there was one scientist, Arthur Eddington, who actually proved it. But anyway, that's another story. I'll tell you sometime later. Very fascinating. He went to Ghana, Africa in 1919 to prove what Einstein said is correct. Okay. But let's not go there. What is this thing which carries this message, the wave? So a gravity is associated with gravitational wave. Can we detect them? Okay. So people started looking for ways to detect waves related to gravity, gravitational wave. You will be surprised the technique which they use, people do in undergraduate experiment, which is called Michelson Interferometry. What you do, if two waves come in phase, they amplify. If they go out of phase, they destroy. Interference, which you have read. Except that in school, it is about maybe few meters, and what you have to do is to build few kilometers long Michelson interferometry. Why you need to build few kilometer long? That is because to detect gravitational wave, the sensitivity of change in length scales that is required is very small. How much should be the sensitivity? You know, 1 meter is roughly 40 inches. A human hair is 10,000 times smaller. Okay. A wavelength of light is 100 times smaller than human hair. An atomic diameter is 10,000 times smaller than wavelength of light. A nuclear diameter is another 100,000 times smaller than the size of an atom. To detect gravitational wave, you need to measure length changes 10 to the power minus 18 meter. That is the technology which has to be developed. You can measure length changes, change in length of the order of 10 to the power minus 18 meter. And people did it. 2015, gravitational wave was detected. What I will show you in this video is this wave was generated by collision of two black holes, which are something like 100 times or 80 times heavier than our sun. And believe me, it happened 1 billion years ago. That wave passed us, 2015. And the signal that is generated on the detector was converted to sound, and today you will hear that sound. So in that way, you are hearing the signal which happened 1 billion years ago. Okay, let's see. Just watch this video. 1.3 billion years ago, two black holes, they came closer and closer. Because of this curvature of the space-time, they rapidly come closer and closer, and then they collapsed. That shook the space-time fabric. Waves, gravitational wave propagated. Okay? This is a simulation. Of course, we cannot take that photograph that time. This is simulating the physics or the process which happened. They came and collided and reached this experiment called LIGO. That's the sound. So what you are hearing today is this signal converted to sound of two black holes colliding 1.3 billion years ago. So the gravitational waves were discovered. As you see, it's such an important occasion. It got its due attention, and Nobel Prize was given in 2017 to these gentlemen who led to the discovery of the gravitational wave. Barry Barris, his son, is my collaborator, and Kip Thorne comes in, he has done some movies also that you may be knowing. Okay, so that is about what excites me in high energy physics. Three things: electron mass and why we exist, gravitational waves, gravity is something very different, and creating a microsecond old universe in the laboratory. Now all this money and effort that we put in, does it have any application at all? I can go on and on saying that since 1930s till now, whatever technologies we develop has entered mainstream society, and they do transform life. And I will give you some examples. There is a list of topics, but I'll tell you one story and then I'll give you two examples. When this laboratory was being built, specifically Fermilab, when it was getting built, why I say Fermilab? Because they build accelerators which are now being used for cancer therapy. When it was being proposed, then it was a few hundreds of millions of dollars, and the question from the Senate, their parliament, was that there is no money for food, there is no money for shelter, basic needs, and you want to give away so much money to build a facility, what for? He said, I want to do science. He said, for what for? And so he was just telling that, yeah, I need to just do science. Then they said, no, can you relate it some way to defense? He said, no, I cannot relate it anything to defense. Then why should we give you money? Then he thought about it and he asked the committee, why do you have soldiers? Then they were very happy, the parliamentarians or senators. They said, we have soldiers to defend our country. Then he showed this, in that sense, this new knowledge has all to do with honor and country, but it has nothing to do directly with defending our country, except to help make it worth defending. If you pause and understand what he's saying, why do you need soldiers if you have just a desert? Only people will be interested when you have some things which nobody else has. I am going to build a laboratory which will make America worth defending. That's the reason you will have army. Not that you have army and I want to fund. And he got it. And Fermilab, of course, led to many Nobel Prize from that accelerator. Today I will just tell you about two applications. Many of you may be knowing, many not knowing. The World Wide Web had started at CERN. Okay? It is one in the chain of what we call internet. In 1989, Tim Lee, this is the computer, he first formulated the World Wide Web. And in 1993, as high energy physicists do, they never keep anything to themselves. It's all made public. CERN gave away this technology to public domain. No royalty, no patent, nothing. We never do patent. We give it free. And they gave it to the whole world. And that's how our users of internet is increasing in India. That's the projected in 2025. That's where the impact of internet is anywhere, any domain, especially during this pandemic time. And
So there are few other technological advances in history which have made more profound effect on global economy or social interaction than World Wide Web. And that started because we needed to exchange our idea between our collaborators freely and effectively. Okay, now you can see what is its percentage of GDP, or how does web lead to increase in revenue of different companies, or how is this internet and GDP growth increasing. All this data is available, that's the source, and you can see that no country with strong ecosystem and low internet consumption, its internet consumption is somehow, digital aspects are somehow driving the revenues of the world. Okay, so that's one directly coming from high energy physics. The other is cancer therapy, both on therapy as well as instrumentation. This is one projected incidence of cancer statistics in India 2020. You can just look at the last column. That's the risk. 1 in 9 is one would expect cancer hitting the population. 1 in 9. Okay? And different kinds of cancers, how many, what is the risk? 16, 1 is oral cancer, and so on. It is a big issue. So what does one needs to do? One needs to treat the tumor, whole tumor, and nothing but the tumor. Okay, so the treatment has two important goals: kill the tumor and protect the non-tumor, the good things, the good cells. That's the goal. And also, you should be able to see, in order to know where precisely you need to deliver the treatment, and sure that it goes should be the key. Okay, so you have to see it and then deliver your treatment exactly on that spot. And that's where, again, high energy physics come into play. One is first imaging, of course, Röntgen, X-ray. Then we have George Charpak. He built a multivariate proportional counter for which he got Nobel Prize in 1968. That is again to do high energy physics experiment. But then that was used to get these kind of images of rat brain and kidney, and as a result of this advanced imaging technique, this detector has wide applications in medical imaging. PET scan, I do not want to go, there's first kind of antiparticle being used for therapy. You have MRI and PET scan and MRI taken together to give a better image, and so on. People working to discover Higgs boson, why electron had mass. Okay, he is from Anthony Butler, he is from New Zealand. This is the picture that he is now able to generate from the detectors, the knowledge of detectors which he used in Large Hadron Collider. He is credited with the first three-dimensional X-ray image of human body parts. So, particle physics developed detectors to detect these small particles, to make fundamental science discovery. That knowledge has moved on and has gone into diagnostics and imaging. Then comes therapy. So there are different kinds of therapy: surgery, chemotherapy, and radiotherapy. Radiotherapy is where particle physics contributes. Now, there is this intensity modulated radiation therapy. Okay, I will not go into details of it, how this was improved time and time with our knowledge of physics. Then there is this new kind of imaging therapy which integrates MRI into the already existing techniques. But what I wanted to say is, when you give radiation, okay, normal radiation, it affects good cells and bad cells. So it has a huge side effect. People figured out that instead of giving radiation, if you do particle therapy, that means you radiate with a proton or an ion, then you look at that plot there. If you give radiation or photon, this is relative dose and depth in body, there is a tail, photons, okay? But if you do particle therapy, depending on the energy, most of the energy is deposited at a particular depth. So you can tune the particle energy, and you know the tumor is at that depth. You can choose the beam and deliver it exactly at that depth. It will not affect. You see, before that and after that, this red and the cyan color, the energy, the radiation, which is harmful for normal cells, they do not affect before that or after that. You can really deliver the dose exactly at the site where you want. So this is another example of showing that you can see normal radiation affects all these aspects, but you see if you do particle therapy, this color code shows the effect and there is nothing beyond. So that was what Fermilab first produced, those accelerators for particle physics, high energy physics, and now people are trying to use this. So that's another contribution to development and healthcare system. Okay, I just want to show you that there are such accelerators existing in different continents. The blue ones are existing. We don't have anything in India. It is still on development, and that there are progress going on to have that technology here in India. The orange is there are some activity going on and it is being purchased or put in place. But the blue ones, you can see how much it has developed at other places. By the way, the CERN lab exists here, and you can see the blue. The Fermilab and Brookhaven National Lab exist here, and you can see those kind of applications, how it happens elsewhere in the world. And that's the machine which is being put now. They are trying to prototype it into usable scales so that things can happen. Okay, so that was application. World Wide Web, medical imaging, and cancer therapy, particle therapy. Now I will tell about restoring gender parity in science. I do not know how many of you know Dr. Bibha Chaudhary. Well, if you do not know, that's the book you should read. She obtained her PhD in University of Manchester. Okay? She did her work with D.M. Bose from Bose Institute, Nobel laureate Blackett, joined Tata Institute of Fundamental Research in Bombay and Physical Research Laboratory in Ahmedabad. After her return to India, never got any recognition. You may say, what recognition? Well, many times her name comes up, but she never got her due recognition. Do you know, in spite of what I'm going to show you now? You know, Nature is a journal which is highly reputed, and people strive to publish papers in Nature. She had 3 consecutive Natures. Please note the dates: 1940, 1941, 1942, and please remember this word, mesotron. Okay, mesotron. Okay, this is nothing but today's meson. That time there were many kinds of names given to this particle called meson. Pion is a meson, which led to understanding about nuclear force. She had worked on it. In fact, this is a table from her paper, and you can see the ratio of the mass of this mesotron to electron is 288. The average, if I do average of her readings, and today it's 280. Okay? So she had already seen this new particle. 1940, 1947, Frank Powell wrote this paper, 1947, Nature, I showed you, 1940, 41, 42, and he got the Nobel Prize for discovery of mesons. In 1950, for developing photographic method, let me see, you see, photographic plate, Bibha Chaudhary's paper, photographic plate. What did he get for development of photographic method? Of studying nuclear processes and discovery of meson. Of course, he acknowledged in his book, that's the quote, in 1941, Bose and Chaudhary had pointed it out that it is possible. So she did not get recognition. Okay? 30 years after her death, some recognition came to her in terms of a new star being discovered named as Biva. Of course, this is a big recognition because now her name is associated with an object which we see in the universe. Okay? International Astronomical Union, which is mostly responsible for naming astronomical bodies, in this centenary year, based on suggestions from Indian scientists, named an object with that name as Biva, or which means also light, okay, star and light. So I would encourage you all to read about her life. Remember when she started, it was 19 to 30s. How difficult someone wants to do research, fundamental science, physics, and what hardships she has undergone. Her life is really fascinating to read. And how, in spite of such 3 consecutive nature papers, okay, people get job nowadays with 3 nature papers, she got no recognition at all. So, first important step towards women empowerment is to create, or to identify the role models where people can refer to. Yeah, here is our role model and a woman role model. And she is one in high energy physics. We figured it out. And we are, well, although it's late, but there is a realization. Now you look at statistics of women in science, and as I said, high energy physicists are very sensitive about this. They do look at all these aspects. And if you look at research scholars in physics departments, the blue are women scientists, the red are male. If you look at faculty, again, the red and the blue, okay? If you look at it was mentioned that I got Shanti Swarup Bhatnagar Award. There is only one woman who has got Shanti Swarup Bhatnagar Award in how many? 60 years. Okay, every year they give one in physics, and since independence it has been happening. There's only one. Okay? So on. You can refer to this. So what could be the reasons? There are several reasons I have listed there, and what could be the solutions? I will not go into each of them, but what I'm saying is our community has recognized it and are taking steps. It is for all to look into these aspects and see how this society, which is supposed to be 50-50, how this disparity has happened and why. That has to be figured out. Okay? So what has our community done? Our community has done many things, are trying to do. Again, it is late, but we are trying to do. So now there are some gender parity working group created who looks at the policy, how things can change at policy level. And there are something, the first one happened in Hyderabad, it's called Hyderabad Charter, and there are some guiding principles which we encourage people, at least in science, to follow at all levels. Then whenever we hold a conference, international or national conference, we have a session on gender parity, must, so that people are aware of what the issue is. Many times people are not aware. For example, 2020 December, the High Energy Physics Symposium done at NICER had a dedicated session for that. I work in an international collaboration. We do celebrate the International Day of Women in Science. And we recognize the work of these women scientists who are our collaborators. Okay? And of course, there are proposals which are on for International Conference on Women in Physics. So these are our small steps to correct the situations which has gone wrong, and to recognize talents like Biva Chaudhary and give her the due recognition. Of course, the government has also then, because many scientists go and sit at DST, DBT and all other organizations, the government has also taken many steps now. All these have recently started happening, and these are some of the programs. Again, my woman scientist has to make use of this opportunities which has now started coming. There are women scientist schemes. There is institutes under this Gender Advancement of Transforming Institute called Gati program. There are again many financial support to do research internationally, and there are Curie fellowships. There is Vigyan Jyoti, TIFR organizes Vigyan Vidushi, where they give training to young aspiring women physicists or scientists with some lectures on physics at a very pedagogic level and also at advanced level. And these are things which are really turning out to be highly successful. Keep an eye on these aspects, and I'm sure all of you will benefit, and we will restore the parity which is now missing. Okay, so that is all I wanted to say. Let me come to the summary. So on the physics side, I hope I just told you that we were able to recreate in 2005, that's what in my experiment, a microsecond old universe. And what we found is the matter which each one of us, whatever you can see in this visible world is made up of, that flows almost 20 times more smoothly than water at that temperatures. Of course, origin of mass, how electron got its mass, 2012 it was discovered. Of course, listening to the gravitational waves, okay, how gravity happens, how interaction happens in 2015. All these developments in high energy physics led to gain in technology and science, which was used for many aspects. I just discussed 3 things. World Wide Web, that's the image. This is again a scientist who is working in this Higgs boson discovery, Large Hadron Collider. That is the hand of his father wearing a watch, and that's the image. He has taken X-ray image of the hand. And this is, of course, particle therapy that is another field. And of course, as a high energy physics community, we are trying to empower and restore the gender parity in at least our field. That's what we can do the best, and we go and tell others if they can motivate and emulate these directions to empower women scientists. Thank you very much.
Vedant, can I ask one question?
Please.
We have heard to Dr. Vedant the story of empowering women, particularly in high energy state. We acknowledge with thanks. We acknowledge with thanks his deliberations. I know him since so many years, closely associated with him. We all agree that there is a gender disparity in science. We all agree. But what is the reason behind it? Why it happened? These are the steps being taken to overcome that. What has happened? But why it happened? What is the root behind it? Why region 1 by 1, 1, 2, 3? What is region? Why there is gender disparity? विज्ञान क्षेत्र में महिला मान का स्थिति For example, India got independence in 1947, and the Science Day was instituted 40 years after, in 87. After 40 years of India got independence, the National Science Day was instituted. Someone would have thought that a day should be dedicated for the cause of science. After India got independence 40 years. I don't know the reason why the reason, but it is a story, it is a fact. Then coming to women in science, Vigyan Kshetra mein mahila it is a world story also, you know, world story. Not only story of Odisha or India, it is a world story. It's a world story, world phenomenon. In all countries, including America, this is story also. European countries, America, now is a country. The story is not in Odisha or in India, the story is elsewhere also. Story is also elsewhere. Why it happened? The root cause, but it's a global phenomenon. Why it happened? From the very beginning, you scan the story from the origin of science. Why the women are? Why men in the sex, not to not? Yes. Yeah. So why it happened is not the question. Other side should have looked at it. But it happened. But reasons behind. Yeah.
Viewpoint. Please give viewpoint. Reasons behind it.
Any questions from students?
Madam, microphone. Microphone. Thank you so much, sir, for nicely elucidating the history of existence of electron and Big Bang theory, and how electron got its mass, and why it is so important, and what is the significance of green computing, and what is the significance of relativistic study of space and time and gravitational wave, and application of many branches of science related to, that means current applications in cancer therapy, and also joining the worldwide wave through sustainable development. Sir, in the last part of your presentation concerning to the focal theme of this seminar, that means contribution of women scientists, especially from India, Madam Bhaba Chaudhary and Madam Aditi Sen, it is praiseworthy. I hope, sir, you have delivered your presentation in such a nice and simpler way that each and everyone present over here, starting from the postgraduate students to PhD research scholars and eminent scientists from different disciplines, they understand and enjoy your informative talk. Once again, on ISCA Bhubaneswar chapter, I am congratulating you. And now, I would like to invite our director, sir, Dr. CSK Mishra, sir, to felicitate Dr. Bedanga Das Mohanty, sir. Amit Krishna De. Okay. Now it's over to the second presentation by Dr. Amit Kumar De, sir. He is the advisor and former executive secretary of Indian Science Congress Association and is specialized in the field of biochemical pharmacology and nutritional toxicology. He has done extensive work on Indian spices and has more than 60 research publications and 20 books on his credit. He is a fellow of National Environmental Science Academy, Academy of Environmental Biology, Indian Association of Biological Scientists, and so many other organizations of national and international repute. This is our privilege to have you, sir, with us, and we would like to hear from you, sir, on the topic Science Communication, Ideal Profession for Women. It's over to you, sir.
So you will give me that mic. Can I keep this here? Can't keep, no? Mic? Not working? We can keep this water somewhere.
Okay. Thank you. First, I would like to show my gratitude to the organizers, even though I am from Science Congress, one of the organizers, but definitely to Dr. Samantha, Achyut Samantha, Kajal Pada sir, Dr. Both sir and madam, for giving me a scope to talk on a topic which does not need any introduction. because just now Dr. Mohanty gave a lecture, and I think he has done my work very easy, and he actually talked on science communication. And Dr. Mohanty, I would refer 2-3 times in my lecture, because that is what we want. That is what I would be telling you today, and what he has done. He has in his last 2 slides also shown you the scope of taking up this profession. I am talking about the women here, the ladies, how you could proceed. And I continue from where he stopped. And this is a very nice talk to hear from a scientist, because there is a great fight between scientists and journalists. So they do not go together. So that is the problem where we need the communicators, science communicator in between as a bridge. Okay, so we go to the next one. I will go a little fast. So the question came that why we need that. You can understand. Because Dr. Mohanty is a very exceptional man, I would say. Being a scientist, he was talking in a very lucid language. And I think even a person from non-science background would understand what he spoke, which is very difficult for a scientist to say. And whenever we approach any scientist, whenever you go to a scientist, whatever he says, I mean, at least 10% we will understand, the other we will not understand. I mean, I'm talking about the common people. So we need this science communicator, that whatever is coming out, whatever is in the paper, whatever is being done in the lab, because whatever Dr. Mohanty said, all these are flashed in the journals, all these are flashed even in papers and media. But I think very few people, very few students even now, those who have some physics background beyond that, will not understand exactly what is happening. And he talked about Viva Chaudhary, and I am very happy because, you know, he talked and showed about a book which Rajinder Singh and Suprakas Rai wrote. And incidentally, I am now the Secretary of Indian Science News Association, who has brought out this book, and Suprakas Rai is the editor. He was actually the editor-in-chief of Science and Culture, where I am also an editor. So I feel very much privileged to see that, and we are now focusing on Viva Chaudhary to make our students understand who is she, because after become a star, she become a star. I mean, this is correlated, both the stars. And because it was so silent, D.M. Bose was well known. I mean, people know him. We have instituted so many awards and his work, but her attachment with with D.M. Bose, Viva Chaudhary's attachment was not in focus. So it is now coming out. So I must say it is a very nice to hear from you, sir, your talk about this Viva Chaudhary. And that is why we need a science communicator. See, he worked as a science communicator today. Our Dr. Mohanty, he communicated to you and made you interest. I mean, whenever, who are people here in physics, who are people have some interest in Viva Chaudhary would go back and at least see that. And at least will tell, I know this name, what has happened. So this is the focus of the communicators. Okay, so we go to the next one. I will go a little fast. Next slide. Yeah, so the scientific temper which has to come, which Jawaharlal Nehru told about after independence, the creation of scientific temper, where he wrote in his discovery of India. This scientific temper is to be there, is to be created. And it is you who are sitting here has to do it. See, we are all old people now. We are slowly and slowly at the end, fag end. But it is the young generation who has to motivate the society. So the creation of scientific awareness, particularly against superstition. So that's a huge area to fight. And that's a very difficult area to fight. And it can be done only by science communicators. That's why I am focusing today the need for science communicators. because you just heard Dr. Mohanty, that so many scopes are there for women, and the women has an ideal profession of taking up science communication. Nobody thinks of this. Everybody is thinking of basic science, pure science, applied science, doctors, engineers, but some are going for journalism, definitely mass communication, mass, but nobody is thinking of taking up a profession of science communication, a science journalism after studying science. Very few people, because this is a very neglected area. Okay, this pandemic disaster which happened in the last 2 years has created more of this awareness that we need science communicators. You can understand, whatever you are reading now in the papers, in the media, you have to find out the truth. So much of fake news is there everywhere. How do you know which is right? Is there someone to guide you? The scientists won't come down. The research institutes won't come up straight away and open to you. And whom do you go and ask? Why do you wear a mask? How to wear a mask? Why I should use a sanitizer? How I should use a sanitizer? What is Omicron? What is COVID? So what is happening one after another? How do I take precaution? How do I protect my family? I mean, lot of questions that came up in the last 2 years. And this has to be answered. So somebody has to answer them in a right way. And the research which is coming out, one after another, because people are getting confused. Today it says you do this, tomorrow another news will come, you don't do this. This is harmful, this is good. So which one is right? Who is pointing out? Okay, next one. So they are the only one who can fight by means of logic and rational argumentation and make people aware. Next one. So only shouting won't help. See, if I go on giving lectures, just now I am giving you lectures, what will it help ultimately? How many? Maybe 1 or 2 people will go back. What Dr. Mohanty just said, I mean, 1 or 2 people may remember. That's all. But we have to work. Only shouting won't help. We have to go to the ground level and we have to work. Because they said we have enough of experts. Don't do this. But what we should do, tell me. Next. And you know the tools now, variety of tools have come. Both our traditional means, both our new modern means of electron means. That can be used. And all is there with you. Radio, even radio is there. New generation may think, who is thinking of radio? You think of FM only. Otherwise, what is radio? No use. But it still goes to the villages and it's a very big platform to go through. Television is there, newspaper is there, puppetry, you know, it's an old one. See, if you want to attract the children, these are the means also. So you have to use these means. It's slowly and slowly coming back. If we have a small puppet show in our scientific conferences now, to attract people, because now we need people to focus, we need their attention. With the internet in hand, with the mobile in hand, it is very difficult to draw your attention to the screen. Draw your attention to the speaker. Draw your attention to what is happening. More attention is focused in your hand. So world is inside your hand now, within these 5 fingers. It doesn't go out. Just like the frog inside the towel saying that there is no sky outside, only limited small. So your world is limited to this 5 fingers here. Whatever is there is in my hand. Nothing is outside. Whatever is happening is here. Because everything is here, no. So we need puppetry, we need drama, we need songs, we need films, we need cartoons. And obviously the last one is there. And that's the greatest one, biggest medium now, where you can in seconds use that everything, and a very difficult media also. Very difficult part because lot of things are happening there and lot of questions are coming. And the last one, definitely websites and e-journal, like just Dr. Mohanty talked about WWW. So you just heard about that. So what is there? It is there. Next. So this was one of our meetings there where what challenges does it face and how secure is its future, science journalism. So this discussion was there in the Institute of Mathematical Sciences, Chennai. And there was this communicating science is challenging India. Next. I'll just give the summary of that. The summary says that there was a trust deficit. A trust between a scientist and a journalist. Because the scientists won't speak out, and even if they speak out, they will not speak out the whole. There are a lot of problems, lot of drawbacks, because they have their own limitations. And the journalists, whatever they write, the scientist will think that he is not writing in a correct way. I told something, he wrote something. And that is a fault of the journalist, because the person who is writing, maybe he doesn't read, he doesn't study, he interprets wrongly. So that is definitely a fault. So that has lost the whole trust between that, because there are flashy stories. Why? So next one. So what do scientists and science journalists really want? What they really want is a genuine writer. Many new science news focus on the inspiring side of new technologies or discoveries. Very few succeed in bringing out the human angle. See, today I will refer to you so many times, Dr. Mohanty, because whatever he said today, he talked about 3 different discoveries. And he brought out the human angle of doing research and the application in society. See, we are getting PhDs. Many of you may go for your PhDs. You will have a big thesis with you. But once you make that thesis, complete it and keep it, after 10 years you think, what will happen to my thesis? What have I ultimately done for the society? I may have discovered a gene, I may have discovered a DNA, I may have sequenced something, I have discovered a protein. Okay, I got my job after doing that. But what ultimately application came to the industry? What application came to the society? What is my contribution to the society there? Very little. Okay, next one. Now I would focus on some of the institutes, government, non-government. I told what Dr. Mohanty ended up in the last 2 slides. Now I'll just go into a little detail about that. The scope where science communicators are engaged, and the scope where you can take up your profession as a science communicator. It's not that I told you, you don't have to go for a PhD, you don't have to go for a doctor or engineer or big one, or after doing your masters, after doing your graduation, you can sit at home, write and get your scholarship. You can get your fellowship sitting at home. There are a lot of women who could not continue their academic studies because of break. Maybe marriage, maybe some social problem, maybe something. And then they come back after years and feel that I have done my graduation, I have done my post-graduation, maybe I can do something. Yeah, that scope is now open. You can sit in your house and do that. You know National Council of Science Museum, those who make this, those who have the science cities all over India, science centers, everywhere, that is controlled by National Council of Science Museum. And they are doing a course on Masters of Technology, MTech, in Science Communication. And in collaboration with Birla Institute of Technology and Science. So that course is there, and from there they select candidates for different kinds of job all over India. Next one. So there may be demonstrators. See, if you go to any science center, you will find 1 or 2 persons there standing there to demonstrate. They will tell you what is this, what is this. They are all science graduates. And there is a daily remuneration involved for working there. Then there is a posts, so many posts, and it is the science communication post, science communicators, whom they take up, because they are the person who can explain, you know. Then they are there for different DST, DBT, ICMR, DRDO, CSIR. Everybody is giving fellowship for science writer, particularly women who sit in their house and communicate. Next one. Then when they give the advertisement, there they will write that we need science writers. Science writers. See, if any of you are in the habit of writing, or if you want to write, you have lot of scope. You can start writing, you know. Science related website, health related website, science magazines, science research center. So if you are a freelancer, a science student, studied science, freelancing from home does pay the same as scientific writing jobs from home. So I am talking here about studying from home. Next. Then we have this National Institute of Science Communication and Information Resources, NISCOM, CSIR, which was called NISCA, National Institute of Science Communication and Information Research. Now it is called CSIR, NISCPR, National Institute of Science Communication and Policy Research. Name changes, but the function is same under CSIR. So they have this magazine Science Reporter. I don't know how many, any of you read Science Reporter? See, that is the problem. That is the problem. If you really want to know about science, for common, these are all magazines. It's not journal. It is not a scientific journal. It's a general magazines where you can contribute. You can get 2,000 rupees writing an article. And they will take, they are inviting articles all the time. So you write there, you write science fiction. You think of a science fiction story. You write there. They will take up science fiction stories. These journals, Science Reporter, Vigyana Pradatti, Science Ka Dunya, these are there. Plus 11 journals like the Journal of Scientific Temper, popular books. And now they have started MSc, PhD in Science and Technology Communication. See, you don't have to always go after you don't get a net, you have some problem, you don't have to go for a higher PhD in your biotechnology, microbiology and so on and so on. You can go for MSc, PhD in Science and Technology Communication. And there is a great demand now for Science and Technology Communication. Next. Then we have National Council of Science and Technology Communication, NCSTC, DST. In fact, Indian Science Congress is under DST, and I am a part of DST, and we organize Children's Science Congress everywhere along with NCSTC, DST. For years we are conducting Children's Science Congress. So DST will ask for proposal, and you can submit science awareness projects. And they are now asking year of awareness on science and health for COVID-19. Especially for COVID-19 proposals. See, use your brain. You have more brain than all of us. Your brain is always getting rusty. Sit down with your friends, sit down with a guide, think of a project. It doesn't have to be a research project. It is a project for a science awareness. You work at the social level. You go to a village, you go to different places, you go to college, you go to school. You make awareness program, year of awareness on science and health. So you go to different places, you tell the ladies who are in the house, sitting, doesn't know anything, you go to the backward community, you go to the community who doesn't know about anything, tell them about mask, sanitization and so many precautions, and they will give you fund to do that. So it is there. Rajat Jayanti Vigyan Sancharak Fellowship. And huge number of awards. Next one. Next. See, these are all the government recognition. for science and technology, effort in science and technology, communication through books and magazines. See, even if you are writing, many of my students write poems. It's very nice. But if you are a science background, why don't you put some science in that poem? It will be a scientific poem. So like that, outstanding effort in science and technology, popularization among children, translation. See, you can start translating. See, whatever just now Dr. Mohanty said, why don't you take up all these things, translate them even from there and make a presentation. Translating, you have to go on doing it, you know. Outstanding effort in electronic medium. So these are given. I mean, it's not given to only very, very renowned scientists, renowned journalists. No. This is very open. Everybody gets. I mean, if you are really contributing, you will get. Next one. Then this AVSAR, which is AVSAR actually. Augmenting writing skill for articulating research. This is an initiative aims to disseminate Indian research story among the mass. Like you write about Viva Chaudhary, her contributions, so that the people know. You write about S.N. Bose. And you write, I am talking about Indian scientists, but you can go to anywhere in the world, any scientist. Then you write their research stories to the mass, for easy to understand and interesting format to the common people. And PhD scholars and postdoctoral fellows in science and technology would be encouraged to write at least one popular science article during their fellowship and participate in national competition. And this fellowship is given. You have to write. Next. India Science Media Fellowship. This is through the Wellcome Trust, DBT India Alliance and Nature India. This is given to the journalist to appreciate scientific process and tell stories of science. You have to write, you have to enrich people's understanding of science and related policy issues. Next. So this aims to train corpus or young reporters in science journalism and create new rooms. So this is specially open in the field of biomedicine, life science, application-based or basic biological research and health. And this gives up to 1 lakh to 5 grantees every year. So this fellowship you can get. Sitting at house, you can apply. People do not know about these things. I am just giving you have ample scope to think of this and apply. Next. Vigyan Prasar. I don't know how many of you know about Vigyan Prasar. You go to these sites, whatever names I am telling you, you go to their sites and start seeing the sites. Vigyan Prasar, they are training program on science journalism, science communication, and they do it with other institutes. And they will give funds. Next, like I told you, I am from the Indian Science News Association also working there. And along with Vigyan Prasar, we are conducting a training on science journalism, science communication and media practice. For last 34 years, we are doing science journalism courses. And we are training. I have more than 200 students with me working on science communication throughout. And they are working and doing. And Vigyan Prasar is funding. So if you have an organization, if you know organization, if you know your school, if you know your college, persuade them and apply to Vigyan Prasar, they will give you grant. And you can work with their fellowship. Start working. You go to an NGO, a registered NGO obviously, you can work. You can develop materials, software materials, organize popular science events. So we are doing this, and all the time you can see in the Facebook, everywhere we are announcing. Even today our lecture is there from 5 o'clock. Dr. Venkat Saran of DST Scientist F, Vigyan Prasar, is going to give a lecture to our students. That's why I was contacting Dr. Mohanty. I will have to call you to talk to my students. definitely. Next one. So they advertise posts, and the posts are in the name of project consultant, production, project manager, content. These are all science communicator posts, mind you. Senior project technical officer, project assistant manager editorial, English, project assistant manager editorial, Hindi. Then we have project manager science communication, science channel, they have science channels. Then project associate, content editorial coordinator. So these are there, no? They have India Science News and feature service. You can go to your mobile and see all this, India Science News and feature service. They have a journal called Dream, which comes out, and they ask for you to write and they will give you money. So when you have any spare time, you are studying science, if you have any spare time, go and sit down and start writing. Whether it will be accepted or not is not important. You go on writing and start sending. If you have any problem, my email is there, contact me, I will help you. Send it to me, I will edit and correct it and give it to you. Don't worry. You can tell Dr. Kajal Parasar is there, she will contact, she will give my all details. This is my profession, I am doing it for all my students. We are bringing out e-journal, e-magazine, Scientifica Communica. It was released only 2 days back. We have released that Scientifica Communica on 28th February, National Science Day. The next issue, which is in the e-magazine. You can contribute there. Next one. Then we have this TDU Nature India Media Fellowship in Science Journalism, started by University of Transdisciplinary Health Science and Technology. So that has started here, in Bangalore, with Nature India. They are supporting science journalists. Next. Besides this, you can have this Science, Nature, New Scientist, Scientific American. All this will always take writers. So if you are going, anybody is interested going abroad also, you can think of this. It's not always your working postdoc in a research lab. But you have this open. This Current Science. Current Science is our Indian journal from the Bangalore Indian Academy of Sciences. They have a fellowship called S. Ramaseshan Fellow. And they will give you sitting at home. My wife is here, Dr. Meenakshi De. She joined in a college, she was Calcutta University professor. Before that, after her PhD, she was sitting at home and writing as a Ramaseshan Fellow, getting monthly stipend. She is a living example here itself. So this is open for fellow. You can write in bioscience, literature, journalism, mass communication, wherever is there you can have interns and fellowship. Okay, next one. India Bioscience. They look for creative writer. National Center for Biological Sciences. They want scripts for biology focused education, animated videos. See now YouTube. Many of you are making YouTube and putting up in the YouTube channel to get likes. And the more like you have, definitely you will be more acknowledged. But whatever YouTubes you are making, that is also creation. So you can start making scientific YouTubes and host. And you can keep that. And you can apply to this, that we are making this type of YouTube, and this type of documentaries, this type of program. And you will be funded for that. Officially. Money will be given to you. PhD in biological science or relevant design. So after PhD you don't have a assignment, go for this. Next. Then we have Indian Science Writers Association. This is one of the oldest association where the science writers are there all, and they also in different time give different type of posts. This I am now talking about NGOs, some of the NGOs. Next. Getting hang or what? Indian Science Communication Society. This society is bringing out Indian Journal of Science Communication, training course in science journalism. So this is going on. You can go to these sites and see, whoever, see, my today work is to just introduce you to this. And you know the names now. If anybody is out of so many sitting, maybe 1 or 2 will be interested. But at least we will get at least 1 or 2 persons working as a science journalist later on and a communicator. Yeah, next. All India People Science Network. NOSTC, Network of Organization for Science and Technology Communication. So these are all for science communications. And you will have lot of job advertisements there. And you can go to their sites, become member of these associations, wherever you want. These are all NGOs. Next. International Institute for Applied System Analysis, IISA. This has research type science communication fellowship in Asia, America, Africa and Europe. All over. So they will be giving fellowship and opportunity for 2-year career science communicator on hand-on experience. 2 years, they will be calling you. You can be with them working and learning and getting fellowship. Next. So very few people would, get an advertisement where places fill up a post for science communicator. No. Just what I said previously. Next one. This has done, no? Next one. Next. So they will be advertising for scientific writer, senior scientific writer, healthcare writer, regulatory writer, scientific writer and editor, medical content writer. These are the industries mainly. The companies, the publishers, they would be writing. Advertisement. You can go and see any advertisement like that. Jobs. These are all jobs. Next. And definitely you have job in NCSM, Science City, Science Museum. All related to science communication. Next. Now, internationally there is a great demand now all over the world for science writers, science writing editor, lead science writer, data science writer, science copywriter, medical writer, life science reporter, science communication specialist. So these are the names through which they are advertised in everywhere. Next. So you can have even for script writers for science shows, YouTube channel, which I just said, and they involve remuneration. Next one. Night Science Journalism Program. These are all free, most of them are free. This Night Science Journalism Program of MIT, you can go and register online. Everything is online. You register and they will give you a timing of the course. You attend the course, they will send you a certificate. These are all free, nothing, only you have to register. And they will bring all the science writers there, writers of different magazines, writers of newspapers, journalists. They will talk with them about science journalism, how to proceed, how to get data collection, and so on, so on. Then they have huge freelance writers for these outlets, the Dallas, the New York Times, MIT Technology Review. Then this American Association for Advancement of Science, just like Indian Science Congress, which we are having every year. I would be ending very shortly. There is a British Association for Advancement of Science, BAS, long back, which you heard in the morning, our two founders, Macmillan and Simonson. They originally started Indian Science Congress with the motto of having a science fair, which was done by the British Association for Advancement of Science, BAS. So similarly, we have American Association for the Advancement of Science. And they have fellowship. They have Science and Engineering Fellow Program. And they will have this type of work done. And their fellows work as journalists in different media. In National Public Radio, Los Angeles Times, Word, and then so on, Nova, and so on, so on, so on. This is international picture. Okay, next one. So the demand is there. The new scientist. If you are reading a new scientist, you know the magazine which will give you news. New Scientist and Scientific American. I am not talking about journals. I am not talking about hardcore scientific journals. I am talking about magazine types where there is news. It's open. You can read. Everybody understands what is written there. I don't know how many of you read that. And now the reading habit of books has gone. But you can go to your net online. But this needs difficult because you have to register there, pay. But in a scientific institute, I don't know whether KIT may be having this, most of them. You have Science Nature, no. Like that you may be having New Scientist, definitely your library. So Scientific American, obviously I think they will have. You go through and see. They are always asking for writers. Discover magazine. So these are there. All the breakthroughs of technology. Next one. Then AJ magazine for climate change. Then we have B culture for genetics, taxonomy and so on. Everyday health for biological research. Science Mag for medical research. Earth Island Journal for natural and social science engineering. Humanosphere for ecology. Hakai magazine for geology in chemistry. So whatever is your field, you don't have to contribute a research paper, please. I am not talking about any research paper. I am talking about write-ups, reviews. It's not that you, whatever is doing, it's your work. No, it's a collection of work written in your language. Don't copy it, please. Otherwise, you will fall in a plagiarism problem. You mention the source from where you have taken whatever material you gather, no problem. But you write from your own. Start collecting a database and write. Next. But you have your obstacles. This profession is not very easy. You have obstacles because there is a lot of gap. One of your friend writing on a topic, you say, you are writing on Vibha Chaudhary. I would like to write on Vibha Chaudhary. Then he and she will fade out. Then because he thinks or she thinks that is a competition. Difficulty is there. Then proper planning. Then cultural, political opposition is the greatest one. So if you something write which goes against the society, very difficult. Scientific fear of media distortion, which I told about. Then bureaucratic and legal obstructions. Another, you go to a factory, you see some sewage coming out and falling. You are writing on that sewage that it is polluting this pond. And there are people who are bathing. You tell these people, don't bath. You will have an obstruction, legal. But you have to fight. The huge number of journalists who have given their life fighting for science. Next one. Okay, but don't go on telling them that I want to give you a lecture. No, nobody will want to hear. Even though I am giving you a lecture. But I think you will like to hear some of this. Next. So we have difficulty in local language. So that is another headache. Because whatever is written is in most of the English. But we have to make it in our local language, no? You write in Odia. Whatever is there, because people in Orissa may not be knowing what is there. I am from Bengal, so I write in Bengali. So local language is very important. You have to write. And scientists will want to keep their secrecy, but you have to. Now once they understand that he or she is not harmful and really reflect my idea, they will do it. And main problem is communication discouraged by the managers of the industry, and science communication is a waste of money. That is why media doesn't do science. They don't write. They try to avoid science, most of them. Nobody will read. We don't have TRP. What is the use of doing some program? You have so many scientific, programs or serials in television. But how many scientific serial, Life of a Scientist? I don't think. Somebody would make a serial on Vibha Chaudhary, her life and struggle. I have been doing drama. My wife participated with me in the drama Louis Pasteur's life, one after another of life on the drama. Like that we can do. Next. So I would now say, I'm sorry I took a little bit more, 4-5 minutes. Like he says that you want in simple bulletproof format. And bulletproof means gun and bullet too, this person. So it is like that, but we don't want to take up a gun and fight, but it is your pen which has to fight. So that's why this is my motto, and I am again grateful to Dr. Manti for the introductory part. I mean, whatever you said is an example. Sometimes it's very difficult to give you an example. And he gave that example, extraordinary lecture by a scientist, which should be our take-home message. And definitely if you want any profession in science communication, and if you want really to earn something and write something, contact me. No problem. I am there, open to you. Thank you. Thank you so much. Okay.
Thank you, Professor Digi. It was a very nice talk and a very different kind of topic, science communication, where in fact many of the scientists do not seriously think about. But this is very, very important, because as you were telling that how many of the students are now reading Science Reporter. So when we were students, because there was no mobile phone, so we had to read the Science Reporter every day. So time has changed, technology has changed, and that's why, as you said, people are looking at their palm, the mobile. Maybe that can be used usefully, and very nice, a kind of different kind of talk. I couldn't thank Professor Mohanty, as he is an example of how a scientist can also be a good communicator. So excellent talk, both the talks should be appreciated, and thank you again.
Thank you.
Thank you, sir. Thank you, sir, for your nice deliberation on role of science communication and communicators through public participation, and introduce scientific temper into mass and create social awareness against superstitions. Sir, you have enlightened us how science communications through participation in different mode of platforms like radio, TV, television, newspaper, cartoon, and drama create awareness. Sir, you have also spoke about collaboration between scientists and journalists can be possible. Sir, you have also enlightened the knowledge regarding the young researchers about the proposal submission to different funding agency regarding the science awareness proposals, and role of science educator in the society and in the income generations to institutional placements and career opportunity in science journalism and Indian Science Communication Society. Once again, thank you, sir, for nicely elucidating and providing a detailed account of scientific writing and journalism to our students. It was interesting and educative. It was a very interesting and educative talk for all of us. Students are greatly motivated from you, sir. Thank you once again, sir. Now, we will move over to the next speaker. Since Madam Samantha, she's there, madam? So due to the unavoidable circumstances of Professor Samantha, Sasmita Samantha ma'am, she will not deliver a talk. We will move over to the next presenter of this session, Dr. C.R. Mishra, sir. Dr. C.R. Mishra is an eminent chemical scientist and technologist, columnist, television anchor, author, orator, and popular science writer of repute. Apart from his excellence and academic performance, he received more than 100 national, international, and state level awards for his outstanding contributions to science and technology and popularization of science. Dr. Mishra was Deputy General Manager and Head Research and Development, NALCO, and served the Navaratna public sector companies of Government of India for more than 25 years and is considered as a leading aluminium technologist of our country. He had received many awards, among them National Research Development Corporation Award, NRDC, Government of India, Independence Day highest National Meritorious Invention Award in Chemical Technology in the year 1997. He was the first ODIA scientist to receive this award. Please have a big round of applause for him. And he has also awarded with CSIR Government of India highest National Technology Award for Best Invention in Chemical Technology in the year 2002. Sir, I am welcoming you for your presentation. Over to you, sir.
Thank you so much, madam, for a brief presentation. I have taken permission from Kajal madam to speak in my own language, Odia. I think you will appreciate it and you will like it. Any objection to Odia? Okay, thank you very much. आमे वर्तमान दुईटी भल सुंदर भाषण शुणिले विशेषकर वेदांग बाबू मोर सान भाई जी हे अत्यंत मोर स्नेह श्रद्धा अच्छी प्रति भल पाइबा अच्छी 2015 मसीह से जो भाषण अवार्ड पाई दिल्ली में फेरवार किसी दिन पर मुझे इंटरव्यू नहीं दूरदर्शन रे आपन देखिए सर यूट्यूब रे अच्छी से इंटरव्यूटा यूट्यूब रे अच्छी देखिए आई थिंक लार्ज नंबर ऑफ पीपल हैव सीन दैट लार्ज नंबर ऑफ पीपल थ्रू आउट द वर्ल्ड हैव सीन दैट इंटरव्यू actually his talk was a talk of a science communicator. से जो भाषणटा देले इट वाज नॉट साइंटिफिक टॉक प्रैक्टिकली से जन साइंस कम्युनिकेटर हिसाब रे कथाटा को कहले चमत्कार भाव रे साइंस को से कम्युनिकेटर आपण मान ही डिड द रोल ऑफ एक्चुअल साइंस कम्युनिकेटर साइंस नीड्स टू बी कम्युनिकेटेड व्हाई पॉइंट नंबर 1 विज्ञान कोन साधारण मनुष्य जानिबा निहाती दरकार एटा होय गोटे प्रश्न किसी लोग कहते जो मैंने विज्ञान क्षेत्र में विज्ञान गवेषणा क्षेत्र में फेल मारी था सक्सेसफुल साइंटिस्ट हो पार न से माने साइंस कम्युनिकेशन आड़ को हाथ बढ़ाई था बहुत लोग कही था ओडिशार गोटे चित्र देवी समस्ते जानी जानी ओडिशार ओडिया मीडियम स्कूल मानक विज्ञान पढ़ा हो नाला आज ए सब्जेक्ट जिते विज्ञान पढ़ा आरंभ है ओडिशार ओडिया मीडियम स्कूल मानक से विज्ञानटा इंग्राजी रे पढ़ागला विज्ञानटा इंग्राजी रे पढ़ागला ता परवर्ती पर्याय किसी लोग भाविले जे ओडिया मीडियम स्कूल मानक विज्ञानटा ओडिया रे पढ़ावा दरकार से किसी लोक लेखक जन्म हेले किसी लोक नाम कहबी डॉक्टर गोकुलानंद महापात्र कुलमणि सामल हरिहर पट्टनायक डाक्तर गौरीराणी घोष एमती बहुत लोग बाहर विज्ञान को सरल भाव में प्रांजल भाव में ओडिया लिखिले आज टेक्स्ट बुक्स लिखिले ओडिया मीडियम स्कूल मानक टेक्स्ट बुक रे ओडिया पढ़ाला विज्ञान भाषा प्रथम कर आरंभ है ओके थैंक यू वेरी गुड थैंक यू आई कैन स्पीक इन इंग्लिश आई आस्क्ड ओडिया आई कैन स्पीक इन एनी लैंग्वेज व्हाई इंग्लिश आई कैन स्पीक इन इंग्लिश आल्सो नो प्रॉब्लम When Odia was started, English Telugu also. In Odia medium schools in Odisha, science was not taught at all. When it was started in English, number 2. Number 3, it started in Odia by some eminent scholars, some eminent writers, some eminent professors, like Dr. Gokulananda Mahapatra, Dr. Kulamani Samal, Dr. Gaurirani Ghosh, Dr. Harihar Patnaik, Dr. Gadadhar Mishra Botany professor, all these other professors and doctors, they started writing in English, Odia, science books in Odia. Can anybody tell me the first science communication institute of India or first science communication society in India? Can anybody tell me? So many doctors, they gave you so many emphasis. First society, first institute, first society in India for science population, science communication? Can anybody tell me?
I think it started from
No, it started from Bengal in 48. In India got independence in 47. In 48, again Dr. S.N. Bose. Dr. Satyendranath Bose started the first institute in the country, first society, science population society, though he was a hardcore scientist, hardcore physicist, but an institute was set up known as Bangiyo Vigyan Parishad. Bangiyo Vigyan Parishad. It was started in Bengal, Calcutta in 48. And the next institute in India was in Odisha, that is Vigyan Prachar Samiti in 49. So in Odisha, we have Vigyan Prachar Samiti in the year 49, and it is the oldest scientific society, largest scientific society. Practically all members, all scientists of the state are members of that body. And Odisha Vigyan Academy, what you see today, it was born in 1981, and it was born through Vigyan Prachar Samiti. It was not born by Government of Odisha Science and Technology Department, it was born through Vigyan Prachar Samiti, Cuttack. 49, this is 81. After 31 years. So science need to be communicated. Now whatever you heard about Dr. Bay and Dr. Bedang, science need to be communicated. We are all scientists, all students of science, but are we really a science lover? Are you a friend to science? What Pandit Nehru told, future belongs to science and future belongs to those who make a friendship with science. It is Nehru's statement. I repeat it again. Future belongs to science and future belongs to those who make a friendship with science. Are we really friends of science? We are students of science, teachers of science, researchers of science, but are we really a friend of science? I'm prakutra kana vigyanar bandhu. Number one. Number two, scientific temperament or science communication, science population, whatever you tell it. You know there is a book known as Discovery of India, written by Pandit Jawaharlal Nehru, Discovery of India. It was written by Pandit Nehru inside a jail. You know he was a freedom fighter. He was in Ahmednagar jail in Maharashtra. He wrote that book. In that book, for the first time in the history of India, science communication, scientific temperament, Vaigyanika Manobruti was coined in that book. Subsequently, Government of India, in our preamble, Samvidhan, science communication, scientific temperament was again coined, again by Pandit Nehru. The first book in the country is Discovery of India, where Nehru wrote about scientific temperament. He coined the word, two words, scientific temperament, and that was again coined in the Samvidhan of India, Constitution of India. And we are the only country in the world where emphasis is given to science communication and scientific temperament in the Constitution of the country. Nowhere, anywhere in the world, scientific temperament, Vaigyanika Manobruti, Vaigyanika Chinta Shakti, jo katha hame kohuche, Vaigyanika Manobruti, it is not there in the Constitution of that country. We are the first country in the world. Our preamble, our Constitution contains science temperament. That is the phrase. So science needs to be communicated by whom? Dr. Day told, it can be done by scientists also. It can be done by a non-scientist also. Science communicators need not be a scientist. He can be arts graduate, any graduate, any discipline, but a common man. He can be a journalist or a common man. He need not be a scientist. It can be done by any person interested in science. Science can be communicated not by the scientist, scientific research worker doing science in the laboratory. Any general public, any person, either educated or non-educated, who has affinity for science, aptitude for science, temperament for science, he can communicate science. In the year 1950, 48, 49, 50, another miracle happened in India. And largest, best miracle in the world. In the 1950, Biju Patnaik, our Chief Minister of Odisha, he instituted an organization calling the Foundation Trust. 48, Bangya Vigyan Parishad, 49, Vigyan Prachar Samiti Cuttack, 50 Kalinga Foundation Trust. That trust gives world's highest award in science communication, which has not been touched by Dr. Dey in his slides. Kalinga Prize, have you heard the name of Kalinga Prize? Please raise your hands. World's highest award in science population is given by Biju Babu's Anustan, Kalinga Foundation Trust. Who knows it? Kalinga Prize? Who knows it? Please raise your hands. Kalinga Prize. It started from the year 52, and the first man in the entire world who got the Kalinga Prize was a physicist. In the year 1952, the first man who got the Kalinga Prize in the entire world is a physicist, man from France, Louis de Broglie. From France. He got the first Kalinga Prize for population science. And 52 onwards till 2022, Kalinga Prize is given to the leading scientists, science writers, science communicators of the world. Until now, 69 to 70, I think including this year 70 scientists or science communicators or science writers have been decorated with this prestigious prize, which was started from Odisha. It was started from Cuttack. In fact, it was started from Ananda Bhavan, Cuttack, where Biju Babu was born, his son Nabin Babu was born, and Kalinga Foundation Trust was born. From 1952 to 2009, the name of the prize was the Kalinga Prize. After 2009, there is a change in the name. It is UNESCO Kalinga Prize. From 52 to 2002, for a period of 50 years, entire money given by UNESCO Paris, this award is given by UNESCO Paris, based on the money given by the Kalinga Foundation Trust. For 50 years, entire expenditure was borne by Biju Babu's organization, Kalinga Foundation Trust. After 2002, after completion of 50 years of Kalinga Prize, Government of India thought, Government of Odisha and Government of India Science and Technology thought that is a prize given by a trust from Odisha, and we don't know, and we are not partners. After 50 years of completion of Kalinga Prize, Government of India DST and Government of Odisha DST thought such a miraculous thing is happening from Odisha, we don't know, and we are not partners, we are not collaborators. On their own, they approached the Kalinga Foundation Trust, both DST Government of India, DST Government of Odisha, that we will join hands with you. We will give you some money. Voluntarily they approached us. Till that period, for 50 years, entire money was borne by Kalinga Foundation Trust. After 2002, till date, the money has been decided. It is 6:4:4. In this proportion, this money is given. 6 part is by Government of India, 4 part by Government of Odisha, 4 part by Kalinga Foundation Trust. The award money is $40,000. Einstein's silver medal and a citation. It is given on World Science Day, 10th November, every year in any UNESCO countries, UNESCO member countries. Every year it is given, including Delhi, New Delhi also. The UNESCO Kalinga Prize is now, from 2009 onwards, is given once in 2 years. Name has been changed from a Kalinga Prize to UNESCO Kalinga Prize. Prize money has enhanced from, it was initially it was $1,000. Louis de Broglie got £1,000. It was not a dollar, £1,000. Now it is dollar. It was $20,000. Now it is $40,000. And it is given once in 2 years. And it is the highest power in the field of science communication, science purpose in the world, and only international prize in the field of science from India. That is International Nehru Prize. Nehru Peace Prize is given internationally. From India, it is the only international prize given from India in the field of science or science communication. Even Bertrand Russell, who is a Nobel laureate in literature, Bertrand Russell, he got this prize also. 7 Nobel laureates, 5 women, 5 Indian scientists and writers got this award. But from 52 to 2022, in the span of more than 70 years, no Odia person has been decorated with this award. 52 to 2002, 70 years, no Odia person, I am not talking scientist, no Odia person has been decorated with this award. So one must know this. World's highest award, I repeat it, we should be proud of it, we should know it. World's highest award in the field of science communication, which is not given in the Dr. B's lecture, in the field of science popularization, in the field of science communication, is given from Odisha by a trust, not by government. By a trust for a period of 50 years, and then jointly by Government of India, Government of Odisha and the trust since 2002 till today. As regards magazines, it described so many magazines. How many magazines in Odisha are published in the field of popular science? One. That is the Vigyan Academy, Vigyana Diganta in Odia, and Science Horizon in English. Only 2 magazines. And some other people, on their own, they published some magazines for few years, and it was discontinued after few years also. Vigyana Prabha, Vigyana Deepika, all these things were there. On their own, individual person took interest, spent money, published the magazine, and it subsequently it vanished. So in Odisha today, we have 2 magazines. One is Vigyan Digant in Odia and Science Horizon in English. Both are published around 10,000 copies each. It is going to various schools, mostly Odia medium schools, and this is the only 2 magazines. In the field of English I am talking about. You know, there is a magazine Science Today, Vedang. Bachpan ka Science Today, very good magazine. It is not there. Only one magazine, Science Reporter. Though there are 10 names in Hindi, in Bengali, in Punjabi, he gave 10 to 12 names he gave. But the most popular magazine and only one magazine in the country today is Science Reporter. And Dreams 2050, which started later on, Dreams 2050. Odia newspapers practically do not carry science articles. Practically they carry, but practically they do not carry science articles. Very few magazines, very few science papers, science newspapers, Odia newspapers, they carry scientific articles. From 87 till 22, 87, this award, Science Communication National Award started in 87 till date 2022. Only 8 Odia persons, from 87 to 2022. National Award for Science Communication, only 8 persons, 8 Odia persons. And we are proud of this year, 2022, day before yesterday, 28th, Professor Ramesh Parida got it. From OUAT Professor Chemistry, who is a good writer, let us give him a ovation here. Dr. Ramesh Chandra Parida, day before yesterday, got the highest national award in the field of science writing. Only 8%, he is the 8th person. Since 87, 2022. Long back. 87, 13-14 वर्ष, 26 वर्ष, 22 वर्ष. But it around 30 plus years, only 8 persons. Things need to be changed. Our reading habits practically disappeared. Even people sitting over here do not read newspapers. Whatever, Odia or English, whatever it is, do not read newspapers. I have examples of professors do not have TVs, do not have Odia newspapers or English newspapers. Examples I can give. Today. हमको समय नहीं पेपर पढ़िया पाई 24 घंटा भीतर neither English newspaper or Odia newspapers. We do not read newspaper, forget about scientific articles. We don't have time to read newspapers. We don't have aptitude for writing. Lekhiwata gote kala, it is an art. Like doing scientific research in a laboratory, writing also is a skill, is an art. People say, writers in regional language, they translate English articles from the internet or from the other newspapers, other textbooks, and they give their own color and publish it. It is not a translation, it is a transcreation. It is not translation, it is transcreation. Any regional writer, anywhere in the world,
He has to read English newspapers or some other leading newspapers of their own country and put his own ideas and make a story out of it. There should be a base. Everywhere there is a base. We are created because we are teachers. Our teachers created us. Our teachers are created because their teachers were there. So there is always a base somewhere. But that is not translation. It is not anubado. It is anusrujana. It is not anubado. It is anusrujana. What the award is given, there is an award by given a translation. Professor Gadadhar Mishra got for translation. Professor Gadadhar Mishra, the first ODI man. Professor Gadadhar Mishra, Botany Reverend Psychology, Professor, first ODI man to got the National Award from BSc Government of India in the year I am forgetting, for translating an English book into ODI book. So practically it is not translation, it is actually transcreation. Anusrujana. He is the first man to get National Award and subsequently other people got it. So writing articles, why will write? Nobody reads. Then why will write? Why a writer is writing? Do you think he is writing for you? Do you think he wants name and fame? He wants money, that is why he is writing. Why a writer is writing? Why will write? Without writing can you not live? I can live. Anybody can live without writing. Why a writer writes? Because he likes writing. Not that you read him appreciate. He is writing because he likes it. ଯେମିତି ପରିସ୍ରା ମାଡ଼େ ଝାଡ଼ା ମାଡ଼େ ଭୋକ ଲାଗେ ସେମିତି ଲେଖା ବି ମାଡ଼େ ମହାପାତ୍ର ନୀଳମଣି ସାହୁଙ୍କ ଷ୍ଟେଟମେଣ୍ଟ ଲେଖାଟା ମାଡ଼ିବ ଯେ ଝାଡ଼ା ମାଡ଼ିଲା ମୁଁ ଉଠିଯିବି ଝାଡ଼ା ଯିବାକୁ ଆପଣ ନିଦ ହେବନି ଲେଖିବାକୁ ପଳେଇବେ ଟେବୁଲକୁ ପରିସ୍ରା ଲାଗେ ଝାଡ଼ା ଲାଗେ ସେମିତି ଲାଗେ ଲେଖା ଲାଗିବ ଲେଖା ମାଡ଼ିବ ତ ରାଇଟର ରାଇଟ୍ସ ନଟ୍ ଫର୍ ୟୁ ହି ଲାଇକ୍ସ ରାଇଟିଂ ହି ଲଭ୍ସ ରାଇଟିଂ that is why he is writing. Whether you read, don't read, purchase his book, don't purchase, throw the book to dustbin, doesn't matter to him. Not name or fame or money he will get. He likes, he loves it, he is writing. That's all he is writing. Writing or translating or giving speech, there is a part. You tell cartoon or drama, scientific cartoon, Pathapranta Nataka, whatever you call it. He likes it, that is why he is doing it. Necessarily not that he wants money. Necessarily doesn't know he wants name and fame. He likes it, he is doing research. He likes research, he is doing it. That's all. So that is his passion. It is not a profession. That is not his profession. Writing is not a profession. Pratibha Rao is not a profession, writer by profession. Writer by passion. Shantanu Acharya, professor of chemistry, but is more known as a novelist. The passion dominates the profession. Dr. Kajal Parasar is famous as professor of chemistry. No, professor, he has other quality also. He is a good organizer. He loves people. These are the passionate character of person. Professor is different, person is different. Chittaganda Mahapatra is an IS officer. He is not in the world, known in the world as an IS officer. He is known as a writer. And nobody has taught that writing. Nobody has taught him writing. He loves writing. He has developed his aptitude to growth in writing and is becoming man. A secretary government of India, in India, is not recognized as secretary or secretary there or chief secretary here. He is recognized as a writer. His passion, prabhuti, we call it brutti and prabhuti. Prabhuti dominates brutti. Many examples, Pratibha Rai, Shantanu Acharya, Satyakanta Mahapatra, you tell any man, they are not known in their profession. They are known, but extraordinarily known more in the passion. Extraordinarily known in the society, Pratibha Rai, don't call him a Odia lecturer. You call Pratibha Rai because he is a good writer. You invite Satyakanta Mahapatra now, IS officer, Secretary Culture Government of India. Don't call him like that. You invite Satyakanta Mahapatra to stage because he is a good writer, a good thinker. He can change your thinking horizon. That is why you call him. Gokulanand Mahapatra is a chemistry professor. He is more known as a writer than a chemistry professor. So in the way of life cycle, what happens? Passion dominates the professor. There are very few people in the world. The number one in the passion, number one in the profession. Like my younger brother, Vedant. Good scientist, good speaker, very good communicator. I am very much appreciated. Whatever he told, entire talk was a science communicator's talk. It is not a scientific talk. Actually, what he presented is just talk of a science communicator. Science need to be communicated to the common man in his own language, not his language. I will understand you only when you speak my language. I listen my language through your mouth. So when a speaker or a writer or a thinker expresses his views, ideas, dreams through the language of the readers, language of the listeners, then he becomes popular. So I must understand you, your idea, your brain, your exposure, and I will communicate to you so that it touches your heart. That is the art of communication. His talk was not a scientific talk. He initially told it is not a scientific talk. Practically, it was not a hardcore scientific talk. It was a talk for layman. So communicating science to a layman and communicating science to a PhD scholar is a different thing. Dr. Mishra is speaking you as a science, not as a scientist. My scientist will not be there. Other people will be there. If I talk chemistry or technology, you are not the listener. Other people will be listening to it. So that horizon, that spectrum will be different. The two faces of a man. One is Vedang Mahanti as a scientist, Vedang Mahanti as a communicator. Pratibha Rai as a Odia professor, Pratibha Rai as a writer. So in many cases, extraordinary cases, you find Vritti and Pravritti, you find Pravritti dominates Vritti and he is recognized in his living span of time after his death as a writer, not as a professor of Odia or as a IS officer. Yes, sir, you agree? Sitakanta Mahapatra, Hantuna Acharya, we don't invite to the stage because you chemistry professor or is IS secretary, culture, government of India? No. They have surpassed that stage. And they have made an identity in the entire world horizon through their passion. They are living in a passionate world. Einstein. How you become so big scientist? You know the story, everybody knows it. I am a passionate man. I am not an extraordinary scientist. I am an ordinary person with a passionate man, passionate vision. Extraordinary passionate. That is my plus point. That is the Einstein statement. All my classmates from starting from bottom to up, I am not extraordinarily better than them. So how I became a so much big scientist? Tanko Bapa, Mo Bapa, Kichi Pathakana, Tanko Vitar, Mo Pathakana, how I became a big scientist? I am a more passionate person. So passion identifies the person. Passion gives a new creativity. Passion gives a new identity to the person than profession. The professionally also we excel, number one in the world. In the passion also we are number one in the world, all of the country or the state. The passions give an identity. Vritti gives an identity, definitely Vritti gives you, but physics professors so many, mathematics professors so many, hundreds of universities, hundreds of professors. But how many Pratibha Raj? How many Sitakanta Mahapatras? How many Sastanda Acharyas in Odisha? 4.5 crore Odia Vitake Telko Bharibe. Kahin Bharunati? So many professors of chemistry, so many professors of mathematics. Why you are not creating another Pratibha Rai? Why you are not creating another Santanu Bhattacharya? Why you are unable to create another Sitakanta Mahapatra? Why? You cannot create it. Vedang, you cannot create writers. You can create a scientist, but I cannot create a writer. I cannot make you a writer. You see the statement. I can create a scientist, I can make a PhD. I will PhD de. You see Bhiraman story. See Bhiraman and K.S. Krishnan story. I can make you a scientist, but I cannot make you a man which your father and mother has done it. See Bhiraman and K.S. Krishnan story. I physics पढ़े PhD कर देवी, किंतु I cannot make you a man. मनुष्य थे, जो तो बापा माँ करते नहीं पारी बने. He was selected. He was rejected and subsequently selected as a PhD scholar. K.S. Krishnan. So many things happened. Many character of a person. Basiva, Uthiva, Hosiva, Tarduva, Cholapatolanga. So many things contribute to success of a person. Brain is one, knowledge is one, but knowledge is not everything. So many IS officers, so many secretaries have gone, so many secretaries will come. But can you create another Sitakanta Mahapatra? Can you create another Jagyasini? Can you create another Matimotalo? No. You cannot create a writer. You cannot create a thinker. Chintasil Bhakti को सृष्टि करा दियो. How is man? You can synthesize the man. You can thinker. Thinker par excellence. You cannot create. So writers are thinkers. They think differently, act differently, behave differently. They are different persons altogether. They live in their own world. They communicate in their own vision, their own perspectives, and they have their own place. They create their own place in their world of creativity. So you cannot make a writer. Like a course, photography course, acting course, even a course such a film institute, photography course, acting course, you can create. But true sense, you cannot create a writer, you cannot create a thinker. It is inherent, it has to come through. Evolve, it will evolve. Through your evolution, the brain, dimension of brain, the spectrum of the brain changes over the years. गोटे लेखा मैं वर्ष लिखी 10 वर्ष पर पढ़ी अरे ये तो एमती लिखते भल होता सो इट चेंजेस ये लेखाटा वर्ष लिखी 10 वर्ष पर पढ़ी अरे मुझे आहरी भल लिखि पारता तो थिंग्स चेंजेस परसेप्टिव चेंजेस सोसाइटल स्ट्रक्चर ऑल्सो चेंजेस टेक्स्ट बुक्स चेंजेस नॉलेज चेंजेस इक्वेशन चेंजेस सब जिन चेंजेस वर्ल्ड इज चेंजिंग फॉरम तो साइंस राइटर्स यू कैनॉट क्रिएट थ्रू ए कोर्स you can call MSc, you can pass out. You can pass out MSc course Science Communication, but creating a MSc Science Communication necessarily not that you will be a writer. Or you will be a science dramaturg or science cartoonist. Necessarily he may be, may not be. And the journalistic communication with scientists and journalists, what Dr. Day I pointed out, we don't have science journalism in the state. Science journalist. Do you find any person? Science journalist. Those who only give you scientific news. No. Any journalist can be science journalist. And news on science practically nil. Practically nil. It is not only zero, but practically nil. The science journalist, till now, till date, we have not created. And what Dr. Day, I told, I appreciate it. They don't have affinity for your scientific knowledge. After 2 दिन there conference किया, इतना लोग आए, इतना हुआ, nothing does not matter to them. What matters is who becomes chairman of Bhubaneswar municipality. That is more important than what becomes here. Policy predominates. Other factors predominate over scientific news. Whatever discoveries, whatever invention, whatever work is being done in Odisha, is it rightly projected in the press? No, answer is no. केते विभिन्न लैबोरेटरी एते यूनिवर्सिटी एते वैज्ञानिक काम करछंती तार प्रतिफलन हमर मीडिया रे आसुची कि आंसर इज नो केते भलो काम करछन डॉक्टर वेदांग करछंती सो मेनी लोक पीपल आर करछन दिन रात काम करछंती बट व्हाट एक्चुअली दे आर डूइंग इज इट रियली रिफ्लेक्टेड इन मीडिया इफ इट इज रिफ्लेक्टेड इन द वे इट इज टू बी रिफ्लेक्टेड नो इज इट रिफ्लेक्टेड इन द वे इट इज टू बी रिफ्लेक्टेड नो दैट इज अगेन डिफरेंस बिटवीन द जर्नलिस्ट एंड द साइंटिस्ट the language of communication between the scientist. What the scientist tells, he reports different, what Dr. Day told. So there is a communication gap between the scientist and the journalist. Forget about the common man. There is a difference of opinion between the scientist, what the interview takes, and the journalist, what he publishes. There is a difference between these two senior persons and educated persons. Forget about the scientist and the common man. The common man has a right to science. Common man has a right to science because you are getting salary not from the university, from the tax paid by him. आपन को लागु तो यूनिवर्सिटी दउछथि किंतु एक्चुअली यूनिवर्सिटी को पैसा कोठ आसरा इट इज टैक्स पेयर्स मनी सो ए जनरल पब्लिक हैज एवरी राइट टू नो व्हाट ए साइंटिस्ट इज डूइंग इन द लैबोरेटरी फॉर व्हाई ही इज डूइंग फॉरगेट अबाउट द जनरल मैन एंड साइंटिस्ट what Utkal University Scientific Department doing, Dr. KT knows it, or what KT is doing, Madras University knows it, what IMT does it, do you know it? Even a gap between the scientific research communication, forget about general, scientific research communication between one university and other university is lacking. What Madam Kajal Parasar is dwelling in chemistry department here, does the Utkal University chemistry department knows it? Answer is no. Does the madam at OUT knows it? No. Even communication gap between the scientists from one institute to other is lacking. And we don't have a linkages between academia, industry and research institutes. आमे क्या घर बसी चा पिया को जाऊना we don't like anybody. Academia research institute भल पाए ना, research institute academia भल पाए ना, industry की कई भल पाते नहीं, industry की कई भल पाते नहीं. So linkages between academia, industry and research institutes should be established, so that dissemination of scientific information gets the proper forum for projection. We don't have linkages between academia, industry and research institutes. Between us, the scientific community of the state or the country is reflected in academia, research institutes and industry. And we don't have scientific linkages, personal linkages. Dr. Singh को जाए चाय पीने आ जाए, Dr. Singh मोहर कैसे चाय पीना? We are very close friends. In fact, तांगा टीवी रे भी इंटरव्यू नहीं चाहिए. What is doing? The linkages, scientific linkages between the scientific people. Forget the common man, man on the road. Scientific linkages between the scientific community itself, intra-scientific or inter-scientific community is not there, is lacking. RRL कौन करूँ वो ये जाने ना, because वो ये ता दरबार नहीं घर गला, IMT ता दरबार नहीं घर गला, ये टाटे गले. मोर पापा पब्लिश हला, मोर प्रमोशन हला, मु अमुक है गली विदेश गली, या PDF गली मोर काम सरी गला, बस मु शांति, मु घर शांति, परिवार शांति, पूज्य बड़ा बड़ा गले, आशा गले साइला. So scientific linkages between the scientific community, communication between the inter-scientific community, intra-scientific community is not there. Forget the common man. Sir. तो कम्युनिकेशन बहुत बड़ कथा. आपण काम करंतु, बहुत भलो काम करंतु, बहुत भलो दरमा पाउंतु, प्रतिष्ठित होंतु समाज रे, किंतु आई मस्ट नो इट. सूर्य बाबू ओइटे अछंती, कोन करूछंती, अन्य माने जानिबार अधिकार अछि. एटा संविधान से अधिकार देछि. बिकॉज़ आई एम ए कॉमन मैन, मु टैक्स दोछि, मो जानिबार अधिकार अछि. सर आपण कोन करछंती? अधिकार अछि. आई हैव अ राइट टू नो. That right has been given to the individual person of India by the Constitution of India. That is a very important thing. And common man who doesn't know the ABCD of science, जिता पुओ को पठाए ना, पाठ पढ़िया स्कूल को कॉलेज को पढ़ाए ना, सी कथा कौन? अर्थात communication is not there. It is not there. Practically not there. So these linkages is to be established. Linkages between the scientific fraternity, linkages beyond the scientific fraternity are to be established. Established because unless you establish it, अन्य मानक आपण केमिति जानिबे, आपण तांको भी चिन्ह दरकार, आपण चिन्ह आपण भी भलो न तो मु भी भलो रे ना ना मु खाली भलो आपण भलो न सदै भवन्तु सकिन. आपण भी भलो काम करे पुरस्कार पाउ, मु भी भलो काम करे पुरस्कार पाए. आपण भी पो आईटी रे पढो, मु पो भी आईटी रे पढो. Win-win situation. In English management, you call it win. आपण भी जीतते, मु भी जीते. ना मु खाली जीते, आपण हारते भी जीवन सारा. Win-win situation. तो मो पुओ भी जीतु, मो पुओ भी जीतु. अरे क्लास रे तो गुटे पिला फर्स्ट हो. तो मो पुओ नले मो पुओ. नहीं. तो आपण भलो काम करे खुशी रे रहते पताका उडांतु. मो पुओ भी भलो काम करे पताका उडा. तो जे लिंकेजेस बिटवीन द साइंटिफिक ब्रदरहुड, जो साइंटिफिक ब्रदरहुड कथाटा आसेला, जोटा नेहरू कहिथिले, you must be a lover of science. आपण कौन होते हैं? साइंस स्टूडेंट, साइंस टीचर, साइंस रिसर्चर, से स्टेज रे जीवन सरीगला. माने साइंस टा एंकर भीतर बांधी गला. बियॉन्ड पेरिफेरी ऑफ दिस पीपल साधारण मनुष्य को आसपाला ना. साइंस वाज लिमिटेड टू साइंटिफिक टीचर्स, साइंटिफिक रिसर्चर, साइंटिफिक कम्युनिटी भीतर साइंस जहाँ किसी साइंस रहिला तारी भीतर बांधी के रहिला. बियॉन्ड द फ्रैटर्निटी ऑफ साइंटिफिक कम्युनिटी साइंस कुड नॉट गो. जी नब जहाँ आम साइंस कम्युनिकेटर बोले आख्या दौचु से साइंटिस्ट न पारे, माने कमन मैन न पारे. लिंकेजटा सेटा गवर्नमेंट ऑफ इंडिया एस्टाब्लिश करा चाहूची. लिंकेज टू एस्टाब्लिश लिंकेज बिटवीन साइंटिस्ट व्हाट यू आर डूइंग एंड द कमन मैन. जोटा आप मीडिया कहते खबर कागज माध्यम टेलीविजन माध्यम पथप्रांत नाटक माध्यम कार्टून माध्यम ड्रामा माध्यम साइंटिफिक ड्रामा माध्यम ट्रांसलेशन माध्यम तो सो मेनी थिंग्स आर देयर वेज आर आउट टू कम्युनिकेट योर थिंकिंग. व्हाट यू आर थिंकिंग others should know it. माने आपण गोटे अनुष्ठान अछंती, people should know it. Very important. Your presence must be felt. During your living, after your living. That is most important. So science need to be communicated, and that right has been given to individuals, all Indians, by our constitution. This is universally accepted that science need to be communicated. Even, as I told you, Satyendra Bose was a hardcore physicist. Satyendra Bose was a hardcore physicist. Bange Vigyan Parishad. Started. ISCA story. Gender disparity. Students, question for you. Minded students, question for you. First Indian scientist, ready, ISCA. First ISCA president, ready. And today's ISCA president was already Madam Saxena, Vijayalakshmi Saxena. First ISCA president lady, what is her name? My question to the students. ISCA president, first Indian lady. Clue debi? Madam clue debi? Na, tumi ruho. Pilang bazarche. Tumi teacher. Clue debi? ISCA is a 100 years old society, largest scientific forum of the country, who is the first lady who becomes the ISCA president. Because this question came to mind because today's president is Vijayalakshmi Saxena, is today's president, lady president, or the first lady of Indian Science Congress. Clue debi? Chemistry ro bashchanti dui jana murabi. Chemistry discipline na kahideli. First lady to become Indian ISCA president, Indian Science Congress president. What is her name? She is from chemistry discipline. She is from chemistry discipline. ISCA organize karichi seminar. ISCA ro president bashchanti. Mu ISCA ro pratham lady president katha pacharuchi. Who is the first ISCA president lady? Can you tell? Yes. Professor Asima Chatterjee, Calcutta University. Can you tell the year? Can you tell the year? 75. First ISCA president, Professor Madam Asima Chatterjee, Calcutta University. Tanga field of work koi what is specialization? Madam? Asima Chatterjee's field of specialization? Natural products chemistry. Natural products chemistry. Isolation of natural product from the plant sources. Another man, this is natural product chemistry. Madam, whatever is isolated from the plant sources, whatever chemicals isolated, whatever molecules are isolated, there is another man, he was already ISCA president, but he synthesized those molecules. He is a synthetic organic chemist, number one in the country. Again, Calcutta. Like Asima Chatterjee was a top natural product chemist, similar another top man, number one in the country, synthetic organic chemistry chemist. He synthesized whatever molecules he extracted, isolated, she synthesized those molecules and compared both. Professor Phanindra Chandra Datta, Professor P.C. Datta. Only last question to you. All my students, my dear students, this question you must know. India has a first research institute, kindly tell the name, where C.V. Raman was a student and which institute gave India the first Nobel Prize. I repeat the question. India has the first research institute, Sir C.V. Raman was a student, PhD student, and that institute gave India the first Nobel Prize in physics, till now the only Nobel Prize from India, working in the soil of India. What is the name of the institute? Students, India is the first research institute. It was not Tata Institute of Fundamental Research, it was not Indian Institute of Science, it is not Bhabha Research Center. Then what was it? India is the first research institute where C.V. Raman was a student and the institute gave a Nobel Prize to India. Calcutta, I am giving a clue, Calcutta again. Calcutta. Calcutta, clue is Calcutta. Indian Association for the Cultivation of Science. And till now, that is the only institute which has given Nobel Prize to India. C.V. Raman is the first Nobel Prize, only Nobel Prize winner from India who worked in India. Another question, again in Calcutta. Because these are the days, because day before yesterday I was there. You know, for the first time in the history of India, a Science Week was celebrated. Nowhere Science Week was celebrated. From 22nd February to 28th February. One Science Week was celebrated. 7 days, entire country, not here. 69, I think 69 places you are telling, 69 places Science Week is celebrated, and KIT hosted the India's conference, Odisha conference, from 22nd to 28th. A day before yesterday I was a speaker there. It was in the school, KIT International School. Calcutta is known as City of Nobel Laureates. Calcutta has created more Nobel Laureates, more than one. Anybody can tell another name from Calcutta? Man from Calcutta or a Bengali? Calcutta, do you know Konark Temple? Do you know Konark Temple? Raise your hands. Have you seen Konark Temple? It is a World Heritage Site. Do you know it? It is a World Heritage Site. This designation who gives? Which organization in the world gives that designation to Odisha, to Konark Temple? UNESCO. Where is the headquarters? UNESCO headquarters? Where? UNESCO headquarters situated at? No. अरे सारा ओडिशा रे मात्र गोटे मंदिर आमर अछि जे कि वर्ल्ड हेरिटेज साइट, ओनली वन वर्ल्ड हेरिटेज साइट. Which organization of the world has given that? Is it UNESCO? Where is the UNESCO is situated? UNO, you know the UNO, World, UNO, United Nations Organization. Where is the headquarters? UNO headquarters, world headquarters. मिलित जाति संघ ओडिया रे मको मिलित जाति संघ यूनाइटेड नेशंस ऑर्गेनाइजेशन हेडक्वार्टर वेयर न्यूयॉर्क. Under UNO there are so many other organizations like UNESCO, United Nations Educational, Scientific and Cultural Organization, United Nations Educational, Scientific and Cultural Organization, UNESCO, largest body in the world on education, science and culture. Apex body in the world on education, science and culture. UNEP, United Nations Education Program. UNDP, United States Development Program. So many organizations are there. WIPO, World Intellectual Property Organization, Geneva. WIPO, World Intellectual Property Organization, Geneva. Bishwar Sabu Buddhi Saiti, Geneva. WIPO headquarters. That UNESCO has given that World Heritage tag to Konark Temple. Very recently, on December 15, India's another Ghatana, another story has got the World Heritage Site. On December 15, 2 months before, India got another World Heritage tag. What is that? Clue is again Calcutta. Durga Puja. Calcutta, the Durga Puja got World Heritage tag on December 15. Again by UNESCO Paris. Headquartered is in France, Paris. France Rajdhani Paris. UNESCO headquartered is in Paris. Again, I'm closing the story. Calcutta, City of Nobel Laureates. C.V. Raman. C.V. Raman got Nobel Prize in which year? C.V. Raman got Nobel Prize in which year? Students, my dear students. C.V. Raman got Nobel Prize in which year? And for what work? Raman effect, very good. In which year? Why am I telling it? Because he is the only person in the 90 years of history of India. He got Nobel Prize in 1930. After 30 to 2022, 92 years, no Indian has got a Nobel Prize working in India. Indians have got a Nobel Prize, but working elsewhere. But C.V. Raman is the only Nobel laureate working in India, got Nobel Prize, and since then till date, no Indian has got Nobel Prize. Can you tell other names in Calcutta? Nobel laureates in Calcutta? Rabindranath Tagore. In which year you cannot tell. For which book you cannot tell. If you tell one answer, other answer don't know. Rabindranath Tagore 1920. For which book? For which book? Gitanjali. Then you know it. Then other names. Mother Teresa, you know Mother Teresa, Karmabhumi, Calcutta Sahara, Mother Teresa, you know it? His workplace is Calcutta City. Amartya Sen, Abhijit Banerjee, do you know black holes? Dr. Vedang was talking about black holes, collision of black holes. Who discovered black holes? Is an Indian. Indian, not only Indian, Indian Nobel laureate. Working outside India, what is his name? Clue, in the family of C.V. Raman. In one family from India, 2 Nobel laureates. C.V. Raman Kokai, Putra be Nobel laureate. Yes, Chandrasekhar. Subramanyam Chandrasekhar. Discovery of black holes. In which university he was working? University of Chicago. University of Chicago. Our Professor Pradhan was a student in University of Chicago. Professor Tilochana Pradhan, who expired recently, is a student of Chicago University. India is a science city. What is the name of India as a science city? Can you name India as a science city? City of joy. Which city is known as the city of joy in India? Kolkata. Which city is known as scientific city? Bangalore. Thank you so much, madam. So let me conclude the story. We have many things to know regarding our own heritage, our own science, our own culture, our own scientists. Last question. ISCA, Indian Science Congress Association, first president of India. Who was the first ISCA president? Again a clue, he is a Bengali. ISCA was the first president. ISCA was the first president. Madam is the ISCA secretary. First president of India is the first president ISCA. Sir Ashutosh Mukherjee ko, Ashutosh Mukherjee ko. Sir Ashutosh Mukherjee. Do we know, again another question. Ashutosh Mukherjee was the taught in his home by a Odia man. Can you tell the name? No? Home tutor. Ashutosh Mukherjee kiye padhitile ghare? Kulabruddha Masudon Das. Ashutosh Mukherjee jo diary lekhishanti, biography lekhishanti. Read that book. Ashutosh Mukherjee ko tako ghare ପାଠ ପଢୁଥିବା ହୋମ ଟିଚର ହେଉଛନ୍ତି କୁଳବୃଦ୍ଧ ମସନ ଦାସ, ମଧୁ ବାରିଷ୍ଟର, ମଧୁବାବୁ ଯାକ ଆମେ କହୁଛୁ. You must know it. Thank you so much.
Thank you so much, sir, for your presentation regarding science communications, the way forward. Sir, your brilliant statement regarding the future belong to those who make friendship with science, encourage young researchers, and move forward and make friendship with science and having a passion for doing science. Sir, during the course of presentations, you have given different awardees of our country who popularize science through different platforms. Sir, another brilliant way of communicating science to popularize it through how it can reach to the common man. That means whatever the scientific finding we are doing in the lab, that should reach to the land. That means lab to land transformation. That means in that way, common man can get the benefit of science. In this way, now the vision and that means the vision of science of India, it's progressing through different missions like ICR and CSIR. They are popularizing science through different programs like Mera Gaon and Mera Desh, adopting different village, adopting different farmers, and communicating their science to farmer platforms. And CSR also has its significant program in securing livelihood security of tribal peoples through CSR floriculture missions and many more. Sir, you have enlightened us. That means how science communications can be possible through different platforms. So now, since we are running out of time, so I would like to invite our last presenter of this session, Dr. Dinda. He's a professor, he's an associate professor in the chemistry, PG Department of Chemistry, Utkal University. He had completed his PhD program. He has completed his PhD program in National Dawn Institute, Taiwan in the year 2004 and 5. He had done his postdoctorate degrees from University of Joseph, France. He received different international fellowship and also national fellowship from Ministry of Education and Culture. He had served more than 20 years, and the most significant achievement of Dr. Dinda's group are the easy and straightforward synthesis of gold carbons from gold N heterocyclic carbons following disproportionation pathway and application of organogold for anti-cancer activities. Sir, I would like to, that means handed over the sessions to you for your presentation.
Thank you, madam, for your kind introduction. First of all, I thank the Indian Science Congress Association and Kajal madam and Sujay sir for giving me opportunity giving the talk. Today, I mean, after so many inspiring talk by Professor C.R. Mishra and so many speakers, I don't know how much I can encourage. So I will try my best. And first of all, I will say in Utkal University, in a small lab, we have started some of the work. And some of work I have done before coming to Utkal University. We have our target to synthesize some compounds, and that is basically organometallic compound, and our target to apply the compound, or we are looking for sort applications, how it can apply for the society or how it can be beneficial. Okay, so my topic is organogold based on N heterocyclic carbon chemistry. Okay. Before going to this gold chemistry, everybody know that, I mean, if you look at the premier history, our grandparents, they have used Sarnavas. Sarnavas, I mean, we have several applications for asthma, rheumatoid arthritis, diabetes, and a lot of, I mean, even though that time cancer disease. But that time they don't know, from the gold, they have generated gold nanoparticle. Because that time conceptions of nanoparticle didn't start. Taking the knowledge from these things, we have started some chemistry having gold. And if you look about this rheumatoid arthritis, the drug still now used, that is as the name of Radura, but it's, I don't know which pointer I didn't know. What pointer did you know what it is? Yeah. Okay, okay. So if you look about these things, ornithine, this is a pediatric medicine still now used for rheumatoid arthritis, and this is hugely used. And if you look about this drug having gold as a metal, and we have sugar content, and another group which phosphine group is there. If you look about this periodic table of chemistry, nitrogen and phosphorus, they belong to the same group, and there is lot of disadvantage of phosphine. And beyond that, we have, if you substitute phosphine by other group, then we see that we got some advantage, or we have some facility. So in that sense, we have substitute phosphine by that is organometal compound, that is N heterocyclic carbene. Because phosphine sometimes gives this phosphine oxide, it is not healthy for human body. So there is some good relation between phosphine and that is carbene. We have compared this one in respect to the phosphine. Carbene is more strong sigma donor, and if you look about this, I have not discussed about that catalysis. If you look about the chemistry, the substituted R group is directed towards the metal, but if you look about the phosphine, that are F of the metal. So they have different catalytic aspect, but today my topic is not catalytic, so that is why I am not concentrated on that one. So today my topic is that biological application of the gold compound. Okay. First of all, you have to know about the N heterocyclic carbene. So N heterocyclic carbene is nothing but when because carbene we know that is a 6 electron valence electron deficient molecule, and it's very difficult to stabilize because we have this this electron and they sometimes is coupled. So it is very difficult to keep them, or it is difficult to bottle up. But we have N heterocyclic carbene when they have attached at least one nitrogen, then it is called nitrogen heterocyclic carbene. And there is several type of carbene we can module, we can generate, and we have also synthesized. And there is a lot of advantage of this carbene I will show later on, because if you look about this main frame, there is imidazole is there. This imidazole has a lot of advantage, and I can tell you that this carbene can be used in the several fields. They can be hydrogenation reaction, they feel olefin metathesis, asymmetric catalytics, and mostly today I will discuss about this only these things, that is the pharmaceutical application of the carbenes. Okay, only one thing I will discuss about these so many applications. Yes, sir. And point is that if you look about the bonding site, the carbene can be bonded with that one that we call normal carbene, but there is another site that is called abnormal carbene, and they have different type of donor capability. So based on this donor capability, we have designed several type of catalyst. And another important information is that this N heterocyclic carbene, what is the topic of my discussion, is much more stable than that of the another type of carbene. If you look about this top type of carbene, they are very difficult to stabilize, as it is a low energy, near about 80 kilojoule energy less. So that is why it is much more stable. And so, yeah, and these are stabilized by, in chemistry it is a hardcore chemistry, they are stabilized by both electron donation and back donation. That is why we call it a push-pull mechanism. Yeah, first N heterocyclic carbene was discovered in 1991, and this is the compound first discovered by Hadron, and he has stabilized this compound and he has bottled up this compound, because I told you that it is very difficult to stabilize this free carbene, because when this electron is there, they will couple with another molecule and they will give another type of compound. But you have stabilized this compound, taking the catalytic amount of and they have crystallized this compound and they have crystal data also. So these are the story first published in the Jack's paper when it is discovered. These are the several methods of synthesis of the carbene complexes. There are several methods. I should not discuss about this one. But point is that these are about the carbene. I have very inspired about this talk of Confucius, the great Chinese philosopher. Whatever we read, I think we forgot. What I see, we believe. And what I do, then we understand. This is the very inspiring talk to me, because when you will do something in the laboratory, then what is the chemistry happening that you will be. But whatever we read the book, someday maybe after 10 years or 15 years, you will forget. So, and when sometime we see it, we believe, okay, this is green color, okay, I see the green color. So that is why now I will start my own research, whatever I started in Utkal University. First of all, we have within very limited facility, we have to think about what we can do in this laboratory. So we have generated this pre-carbene, starting with this simple aldehyde and amine. First of all, we have synthesized the C base. From the C base hydroformylation reaction, we have synthesized the imidazole compound. And when this compound is forming or not, by simple doing one NMR, because this is the most, if you look about this two nitrogen, in between this is the proton, and this proton is the highest acidic proton, so that is, this will appear in the most downfield. And if you look about this structure, there is another more singlet proton is there, this one, and so that is why that's appeared this one. So we have fully characterized this compound by NMR and by taking 13C also. As I told that it is very difficult to bottle up the carbene. In our laboratory, we having the simple facility, we cannot do it. So that is why we have taken the several other type of strategy. We have converted we have stabilized this carbene as a compound silver carbene. We don't keep the carbene as a free. We keep the carbene as a silver compound. Question is that how can we synthesize this silver compound, or when it is formed, how easily you can understand whether it is forming or not. By simple doing one by simple doing one proton NMR, by simple doing one proton NMR, we can understand whether my compound carbon is forming or not. Because if you look about this proton signal near about 10.5 ppm, that will be disappear here. If this proton disappear, then you will be sure your compound is forming. That is one point. Second thing is that think about if you laboratory you don't have I think NMR because it's a very costly instrument. So then nothing to do, you have taken the copper iodide, simple copper iodide, and you test it, and then when the silver carbonate forming, that is give you the silver iodide, your copper carbonate is forming, and silver iodide will get precipitated. So having this simple chemical knowledge, we understand that whether our research is going right direction or not. Don't having the sophisticated instrument. Anyway, we have another important information is that whether your carbon is forming, that carbon-carbon signal will be highly shifted. Free carbon that is 148, but when your silver is forming, that is moved to 170. So that should be huge shift. From the shift also you can understand whether it is forming or not. Yes, in our laboratory we have designed this compound and we have synthesized this silver, gold and gold 3 carbon. And this is the single crystal exchange structure because we want to see whether whatever we are telling it is practically forming or not. So having the solid state structure, we prove that yes, whatever expected, that compound is forming. This is silver carbon. And we have proved we don't get the crystal of gold carbon, but we have characterized in a different way, and we have seen that is very similar to silver carbon. Another point is, gold carbon. Another point is that we have synthesized gold 3. Synthesis of gold 3 from gold 1, it is not, very easy. So if you take chlorine gas, passes chlorine gas, then you can synthesize gold 1 to gold 3. But you know that chlorine is a noxious gas, it is not, easy or friendly to use. So we have first in the laboratory, we have taken another textbook knowledge that is called disproportionation pathway, because on disproportional reaction is one will be oxidized, another will be reduced. So here we have taken this gold 1 compound and we have taken another gold salt that will give in the gold 3, at the same time it will give in the metallic gold. And when is metallic gold is that we recovered the metallic gold and again we converted the metallic gold to the gold material. So that is why there should be no loss of gold, nothing. So in this way, this is I will say this is a green synthesis way without using the chlorine and other gases. Okay, and this is the two way we have synthesized. One is called transmetallation method to synthesize silver to gold, and another pathway that is disproportionation pathway to synthesize gold 3 from gold 1. So this is the scheme of the reactions. Okay, and point is that whether whatever we proposing, whether this is following this path or not, it is very difficult to convince the scientific community. So we have followed the mechanism, and every mechanism step we have isolated 3 compounds. We propose this is the way of mechanism to synthesize gold 1 to gold 3, and every step we have isolated the compound, and we have synthesized the single. We have characterized the single crystal exchange structure. From that we say that this is the mechanism, because we have started from gold 1. So we look about these things here, gold 1 and gold 3 is there, and finally we reaching to the gold 3. So that is why this process passed through this mechanism. Anyway, and we have applied this gold 1 and gold 3 compound for anti-cancer studies, and we have seen that gold 1 compound is much more potent than gold 3. And that reason we have thought that probably gold 3 we have thiol protein in our body. So this thiol protein converted gold 3 to gold 1, and this sulfur-sulfur bond is formed. So finally your species which is proactive, that is gold 1. So in all the cases we have seen that we have series of compounds, and we have seen that gold 1 is the much more active than gold 3. Okay, these are the beautiful architecture formed by the packing structure, looks like a stair and looks like a ribbon-like structure. That's not so important. Now I am to the biological applications. Okay, so what is the reason? What is the background to create this kind of synthesis, this kind of compound? If you look about the caffeine, what about drink coffee? This compound is there. If you look about the, we have hemoglobin structure. We have hemoglobin. If you look about the hemoglobin, there is imidazole is there. So imidazole, the species already in our body, and if you look about several application of imidazole, nowadays ladies sometimes in the rainy season use this, red dye that is called alpha having this imidazole compound. And this is acts as a anti-fungal drugs. So this idea give us that if this imidazole compound already exists in our body and this has this kind of potent, so we can mobilize or we can module the compound in such a way that should be biocompatible and that should be less toxic towards several things. So from this conception we have designed our molecule. So this is the background of our conception. Anyway, so another drug, you know that we have used metrozil. Metrozil, everybody during our epidemic problem we take this. So if you look about this metrozil, that also one imidazole compound having the nitro group. And ladies using several kind of metronidazole vaginal drug having their infection in the vagina. So these are lot of drugs of having imidazole in the market. So yeah. Another important thing is that biofilm formation. We have taken carbohydrate foods, a lot of bacteria, and they make a layer, and in between this layer they are packed. If you look about this picture, so because of that, and if you look up here in the teeth, they make this kind of layer. So as a result, we have getting a very bad smell from your mouth. So that sometimes we use some kind of spray. So now I also we have designed some of the compound that can kill this biofilm bacteria or biofilm. Okay. Yeah. So these are one interesting compound we have designed in our laboratory. These are the gold compound. We have synthesized silver, gold, and different type of gold compound. And this is one type of gold compound, and this is also one type of gold compound. They have similar structure. Well, only little bit different is there. Here gold chloride is there, but here there is no gold chloride is there. If we compare the activity of this compound, we have seen this compound is much more potent. And we thought that this chlorine during our, during bioprocess, this will be hydrolyzed and this will give the space to bind with DNA and other things. So that should have better activity than that of the this gold compound, because this is no vacant space for this gold one. Okay. And another idea of this design of this molecule, we know that still now the medicine used for tuberculosis having the pyrazine. So pyrazine has a very biological activity. So we have tagged pyrazine with this our imidazole so that its biological activity would be enhanced. And this we have a plan for using in tuberculosis that is under process. Okay. And we have applied this compound for several bacteria, and we have seen that it effectively kills the bacteria. This is the before treating the medicine. After treating our drug, we have this is the dead bacteria, and we have the same image of this one. And we did the docking theoretical studies, and from theoretical studies also we have seen that our gold compound binds this protein very easily, having our very comfortably. Another drug we have designed this one gold drug, and you know that conjunctivitis is a very very common disease for eye disease for us, and in market several drug is available. One difficulties of this drug is that, or drawback of the drug is that maybe the drug kill your bacteria, but point is that you have to keep your retina and other part intact. There should not be no damage. So we have synthesized this compound, and we have applied this our gold compound in the dedicated eye of this gold, because human eye we cannot use this one, and we have seen that the bacteria, both this is bacteria and viral, both effect is there, and that effectively kill the bacteria and virus, and after killing that one we have seen that there is no damage of the retina. So that is the advantage of this drug, and there is lot of advantage should be done, but still now we reach to this point, but lot of things can be done after this one. Anyway, these are the one applications, and these are the synthetic pathway how we can synthesize this type of gold compound. Another drug we have designed this one, the gold carbon drug, and we applied this drug for the cancer studies. And we did this study in Indian Institute of Chemical Biology, Kolkata. We have artificially developed the cancer to the mouse, and we have applied our drug in a different dose and different days. And we have seen that if you look about these things, this is the before using this drug, and this is after using our drug. And we have seen that these are very effectively reducing the tumor cells. And I have published this paper in molecular cancer, and I am very thankful that after publishing this paper in 2013, I have got several call from Germany and other country. They want to get this drug for further, further application or further development. Anyway, and we have, though this is not a gold drug, we have designs, we have synthesized one silver gel, and as this compound silver is known that already it has silver and itself has some antibacterial activity. At the same time, we have imidazole, so we have a plan to use this silver gel for some antibacterial, skin disease that is under process. Anyway, so another, last point I want to discuss that. So we know that still now cisplatin is the one anti-cancer drug that has been discovered. We have Zeiss salt, one gold on platinum compound that discovered in 1827. And platinum 2 and gold 3, they have they have the similar chemistry, and both are D8 system. But difficult is that you look about this thing, after 1827 we are not able to synthesize the gold compound similar to platinum. Though platinum and gold 3, they give the square planar chemistry, they have the similar type of chemistry, but we are not able to synthesize this compound. And here is very similarly to platinum carbonyl compound, we are not able to synthesize the gold carbonyl compound like this one. But though they have very similar type of chemistry. So in our laboratory, so we have taken the challenge. So with whether we are able to stabilize the gold and platinum having the same carbene ligand. And we are very fortunate that we have synthesized this platinum compound and gold 3 compound. You look about these things, they are very similar structure. And we have applied this compound for anti-cancer studies. And from the anti-cancer study, we have seen that this gold 3 compound is much more potent than that of the platinum compound. And very recently also we have synthesized another platinum and gold compound. They have also very similar structure. This is the paper not published till now. This this working under process. Yeah, these are the synthetic procedure to synthesize this compound, and we have kind enough that we are got the solid state structure to prove their particular geometry, whether it is exist or not. And we have compared their several geometrical parameter, and they have comparable geometric parameter. And we have applied this compound for lung cancer and colon other cancer. And we have, if you look at it carefully, this compound is, gold 3 compound is little bit much more potent than that of the platinum compound. So, so from this discussion, we can tell that gold is a very, whatever from the primitive age our grandparents have studied, this is a very good opportunity, and there need to be module, and it need to be stabilized by a particular type of organic molecule, then we can use for several purposes. So by this short speech, I conclude that we have synthesized several type of carbon and carbon nitrogen donor ligand. We have synthesized several silver, gold 1 and gold 3 compound, and we have applied this compound in a very small application, several biological applications. Okay, and first of all, I will thanks to DST. They have given the money for this kind of research, and Utkal University Bhubaneswar, Indian Association for the Cultivation of Science, they have helped me to solve this structure, and Indian Institute of Chemical Biology, Kolkata, Jadavpur University, and my PhD student and some of the MPhil student, they helped to the work. And last of all, thank you, sir, for your kind presence. If anybody have any question or any queries, sir, please.
Do you have any question? Do you have any question? Okay. Thank you so much, Professor Dinda, sir, on your topic organogold based on heterocyclic carbon synthesis structure and its application in nanoscience.
As all of us know that the nanoscience and nanotechnology are the areas of current cutting-edge science in the current areas of research. Sir, you have told regarding the gold nanoparticle in Sorna Bhasma and gold nanoparticles with docking studies and about gold NHCs. And you have also enlightened about the silver nanoparticles or silver nanogels, how it helpful in wound healing, and the gold NHC, how it is helpful for cancer treatment. Sir, with your core areas of research, I hope all the students and all the researchers present over here, they have gained more knowledge regarding the nanoscience research and how it is helpful in the current science and technology. Now, I would like to invite our beloved director, sir, CSK Mishra, sir, to felicitate Dr. Denda. Now, I would like to call upon Dr. Mishra, sir, CSK Mishra, sir, to say a few lines about this session, technical session 3.
Already it is quite late, so already all the talks have been summed up by Dr. Rosaline Patnaik. So all of us know that, although many have left already, so all of us know that the talks we heard are extremely interesting, especially that of Vedang Das Mohanty. I didn't even think that being such a high-level scientist, as Bhatnagar awardee, one can be such a excellent communicator, science communicator. As Dr. Chittaranjan Mishra shared, that he is an example how can a scientist be a good communicator. So we had live examples here. So all the talks were extremely interesting, and although because of paucity of time we couldn't interact much, but we know all of them, we have their email IDs, and we can also correspond with them. Thank you again, Dr. Kajal Parashar, for giving me the opportunity to chair this session. And I must thank all the speakers, who are eminent scientists themselves, who have delivered their talks and interacted with the delegates. Thank you very much. And I think this will be the end of today's session. Tomorrow, again, we'll have enjoyable talks, and we have the poster session, which is very important for young scientists. Thank you very much. Yeah, so yeah, we'll be there.